टेंशन मतलब मेरे को पेज दे दो ना, वो वाला। मेरे को तो पहली लाइन यहीं से पढ़नी है। अच्छा, ये आपको पूरा ही आपको बोलना है ना। उधर माइक नहीं है क्या? माइक है क्या? हेलो, हाँ एक ही है।
सर आप और सर बैठिए। More than was
नहीं ओपन
I think about 70
वो
लाइट लगा है टोटल में about 40 30 something is coming to phone other people also
वो बोलिए
online everybody
लिंक शेयर किया आपने सब? हाँ हाँ तो यूट्यूब पे तो ऑनलाइन ज्वाइन किया है। हाँ तो उनको शेयर करो वेबएक्स। हाँ
तो वेबिक्स में शेयर करती हूँ।
लाइट लगा
वो
हाँ ठीक है
वेबिक्स में हमको शेयर करती हूँ। बस तीन
हाँ मैं कर दूँ।
Good morning, everyone. I, Dr. Archana Chaudhary,
I, Dr. Navpreet Kaur,
warmly welcomes you all here at IIT Indore. Honorable Director Sir, distinguished guests, respected faculty members, speakers, researchers, and dear participants. It gives us immense pleasure to welcome you to the 5-day workshop on scientific project management in the age of AI, being organized under the SAKSHAM-ANRF-PAIR initiative at IIT Indore.
we are delighted to see you all here. This workshop brings together perspectives on effective scientific leadership, responsible research practices, and evolving role of AI in managing complex research projects. We are delighted to have you all us with today.
The Saksham ANRF Pair program is a visionary initiative focused on capacity building, collaboration, and excellence in research across institutions. Over the next 5 days, participants will engage in expert talks, interactive sessions, and hands on discussion that will enrich their understanding of modern project management frameworks aligned with the age of AI. We are pleased to have such a distinguished gathering with us today.
To formally inaugurate the workshop, we now proceed with the lighting of the lamp, symbolizes knowledge, wisdom, and enlightenment. May I request our Honorable Director, Sir, and other dignitaries to kindly light the ceremonial lamp.
yeah whatever something you have to do something some innovation is required
Thank you all. With this, the workshop stands formally inaugurated.
As a mark of respect and gratitude, may I invite the Project Director Saksham, Professor Abhirup Datta, to present a flower bouquet to the Honorable Director, sir. Thank you, sir.
I now invite Professor Abhirup Datta, Dean R&D IIT Indore and Project Director Saksham to kindly deliver the welcome address. Please welcome, sir.
Good morning, everybody. Welcome to IIT Indore. This is one of the important project as a part of which we are organizing this 5 days scientific project management workshop. क्यों? हाँ, देखो, view mode में है ना? Mhm. This is also YouTube live streaming YouTube. Many people have Yeah, so this is a very important project called SAKSHAM, where IIT Indore has taken the leadership and become the hub institute to mentor 6 other institutes, including the Vihayla Vishwavidyalaya, Vikram Vishwavidyalaya, Ujjain, and 4 others, namely NIT Kurukshetra, IIIT Bhopal, Bundelkhand University, and Nagpur University. Okay. So, as a part of that, there is a massive collaboration going to happen between 150 faculty members across the 6 spoke institutions and about 70-ish faculty members in our IIT to begin with. That's the proposal we submitted. And about 93 plus independent projects, which is catering to 3 vital themes of advanced materials, then energy sustainability, and health manufacturing technology, medical technologies, yes, HMT. So under that, we have 3 theme leaders who will also introduce the individual aspects of the projects very soon. Professor Sailesh, Professor Devayan, and Professor M. And so it's a massive, actually, if you see the scale of the project, the funding is 100 CR for next 5 years, but I think the funding is not correctly representing the the broadness and the scale of the project, where you kind of are having an interaction between almost 250 faculty members across the 7 institutions. We are going to hire about 93 plus GRFs and about 10 NPDFs and few other staff members. So it becomes like a massive kind of a mini institution of itself, if you want to do that. There are certain areas of interest and some key projects which are kind of coming out of this. But we thought that first and foremost, this particular workshop is very important to start the project, where we bring everybody in the same page. We share what are the best practices of how to manage a scientific project, how to write a research grant, sometimes how to write a proper grant proposal, publish the papers, and also take it through developing a particular concept, developing it scientifically, then the engineering part of it, and finally make it a patentable item, then finally product, and translate it. So there is whole ecosystem starting from very inception of the idea and dissemination of the idea at the end. We will try to cover that in this five days. That's why it is 5 days and all this thing. There will be some lectures from people who are not so good in our perspective. The finance guys were always the trouble people. But there were two people who are assistant register R&D and our register SP Hota will be here to give two vital lectures on how to maintain the books and other things. There are certain useful things like discrimination and practices, how to communicate properly. And so if you go ahead, and also some people from the funding agency. So Dr. T. Thangaraju from ANRF will be joining us online. There will be Dr. Prabhakar Mohanty from DST, and from DBT somebody also will be joining us. Dinesh Dheeraj Gupta, yeah. There are some faculty members from IIT Indore who have already been translating the research and have translated into major industries. So they will also share, Professor Palani and Professor Avinash Sonamane, their experience and the best practices. We have a provision to hire 9 NPDFs. So Professor Sandeep Chaudhary, who was also one of the panelists in an ANRF NPDF selection, will also share his views on what are the best ways to go forward. Professor Ruchi Sharma our IPR chair professor at IIT Indore, will be sharing her views on how to the innovation and IPR rights. And our theme leaders also have their thing. We will also, some of our senior project associate INRF-PAIR will also share how to use essential tools like Subtle AI, which is ANRF now publicizing. It's a very good tool. We have used it, and we will also share how to use it for you. Associate Dean R&D, Surya Prakash, who is also from professor at Computer Science and Engineering, will be sharing some other aspects of AI/ML usage for your scientific research. So that's a whole full house. People who have come all the way and physically present, I hope you will not get bored. Enjoy the Indore city life after the session is over. Don't skip sessions. And people who are joining online should be, we will be marking their presence. And please join through, not just through the YouTube channel, but also through the WebEx link. Unless you do that, Pratosh ji here will not be very happy. They will not mark attendance and you will not get the certificate. Just kidding. So I think we will start with we'll continue with this inaugural session. And we're happy to have our director, sir, Professor Suhas Joshi here, who has been the guiding force in submitting this proposal, conceptualizing the proposal, and how we are running it. So maybe the next in line. So thank you again. We are around, so feel free to interact with all of us as and when you require. Thank you very much.
Thank you, sir, for this warm welcome and insightful opening remark. It is always inspiring to hear from leadership that plays a crucial role in shaping the academic and research ecosystem. Before I invite the speaker, please allow us to briefly introduce our chief guest and keynote speaker, Professor Suhas Joshi, Director, IIT Indore.
Professor Joshi is a fellow of Indian National Academy of Engineering, the National Academy of Sciences of India, and the American Society of Mechanical Engineers. Prior to assuming the role of Director of IIT Indore in January 2022, he served at IIT Bombay as the Rahul Bajaj Chairperson, Dean of Alumni and Corporate Relations, and Head of the Department of Mechanical Engineering. Professor Joshi earned his PhD degree from IIT Bombay and has held prestigious international assignments, including research affiliation at Georgia Tech USA and visiting faculty at the University of Illinois at Urbana-Champaign. He was instrumental in establishing the National Center for Aerospace Innovation and Research at IIT Bombay, supported by the Government of India and the Boeing Company. A distinguished researcher and academic leader, Professor Joshi has led many sponsored research and consultancy projects, supervised numerous doctoral and master's students, and has over 360 publications to his credit. His contribution to research infrastructure, strategic technologies, and institutional development are truly inspirational. We are deeply honored to have you here with us today, sir. I now please invite Director, sir, and we look forward for your guidance and insights.
Good morning to all of you and welcome to this workshop. I think those who have joined workshop in person, I'm sure you will enjoy the 5 days of interactions with the faculty. And there are varied topics here. So I just want to tell you is that how the IIT ecosystem has evolved and what are the things you probably look at and you probably learn from those IIT's ecosystem. So if you take early 90s or early 80s, IITs were primarily the teaching institutions. They actually began with producing a good quality manpower. But somewhere in 80s or late early 90s, the research focus has increased and people felt that, everybody felt that, the IITs should contribute to research also. So it was not that nobody was doing research earlier, but, at that point of time, somewhere early 90s or late 80s, the research component came into picture. So the professors were teachers as well as they started becoming researchers. If you see older professors, they have very few papers, or some of them have very, very few papers or research papers, but they are one of the best teachers and they have taught many, many courses and generations of the students. But they never bothered to convert their projects and what students are doing, their ideas and what students are working on into research papers or patents, and older professors never bothered. But then they actually generated a wealth of knowledge at that point of time. And these students who graduated from IITs, they actually carried those projects and those ideas outside and actually they built their careers on that. It was not that they were not doing research, but they were doing, but they never published. They never aimed at, there was no need to publish those, they need to document in the form of patents, etc. But in 90s, this actually came and then they said, no, you have to now do the research part of it. And then 90s to all those next to 2 decades, the entire community started working on the research and, actually started publishing. And then you can find that thousands and thousands of publications are there. Somewhere in the 2010 or something of that time, 2010 or around that, the thought process came into picture that no, you have to now take research into the next stage, they convert that research into a useful product. And that's where again lot of churning and lot of things happened and IITs remodulated themselves, readjusted themselves, and they started producing entrepreneurs. They started incubation systems developed, incubation ecosystems developed, professors and students started incubation companies, and all those things. Again, another decade or so, in 20s, the decades have come there. That's where the entrepreneurship became very prominent. So the teaching, research and entrepreneurship, all the three things are coexist. They coexist in the IIT system. So every professor you see, he or she would have done a lot of research, some technology transfer, some entrepreneurship, something here or there, depending on the phase in which they have started their career in IIT. So now the professors, if you see the young generation of professors, they will have entrepreneurship venture within 5 to 6 years. In my generation, Entrepreneurship was somewhere distant place. We were hearing, okay, something of that words were there. So though my students have done something after going outside, but they did not do anything inside. But just those who joined 5 or 6 years later to me, they are already in entrepreneurship. Their students are already doing ventures. The professor is involved in those ventures and so on. So now it has evolved as a big ecosystem where there is a huge emphasis on teaching, there is a huge emphasis on research. Every professor is evaluated on all these aspects. Now the models are like they are evaluated based on the technology translation. What is, how many technologies have you translated? Any technologies, have anybody using your technologies? So professors are involved in many of such things these days. So we can say that this is a very comprehensive ecosystem, and you have many things to acquire, learn out of these, and we really want that this whole spirit of education, teaching, research, and transfer of technology, entrepreneurship, all that thing, the spirit we would like to imbibe in all the spoke institutions, professors, students, and then you start churning and you actually start working around these ideas, and then come forward, and lot of ventures and lot of products should emanate from this particular um, hub and spoke model. Though primary emphasis on this hub and spoke model of Saksham is focusing on research, but I would urge all of you to urge all of you not to restrict yourselves to only research. You know, research is one part, but what next? You have to work with IIT professors and ensure that at least some of your ideas are actually converted into some kind of useful products, useful devices, useful technologies. There are many things which you can develop. So every project, even if every project, what we have about 100 projects, even if you consider that every project develops one technology around the project, you yourself have here 100 technologies, and every project will have 3 to 5 publications. I'm sure we have put a target of 500 publications from this consortia, 500 publications. But the technologies are also important, because that is where you have to groom your next generation, and you have to direct those next generations. So definitely about 100 technologies can be developed out of our collaborations. So the let us not limit the collaborations to only for research. You have to expand those the collaboration beyond research, go to technology development, go to product development. Some of these should be actually taken further for commercialization. There are many avenues available for commercialization. IIT Indore has now a big project of technology translation in healthcare sector. We have 150 crore project. We are all promoting the translation of research into technology. So if you come to some level, rest of the funding, rest of the things can be taken care by the other institution or other programs in the institute. Um, so so there is no limit, and don't limit yourself. Don't bind yourself with the objective of only producing. And you people, those who are working in this Saksham network, are the change makers. You don't want to limit yourself. Don't underestimate yourself. You have a lot of capabilities, and together we can develop many things. I think after 2 years or 3 years time, probably we'll get another funding that we would like to expand this network further to include uh, uh, more faculty members. I'm told that out of 43 crores which has come for equipment, we have placed orders for almost 70%. 98% of equipment has been placed. Now all these equipment will be available in the coming 3 to 4 months. Please ensure that your institutions have proper appropriate places to house these equipment, because the money will be paid only when these equipment are installed and running at your places. Otherwise, money will not be spent from this financial year. So it is very essential that it's not sufficient to buy the equipment or place the order. Equipment has to come, equipment has to be installed and running, and you have to give the final payment will be made to the manufacturer or supplier. So that is where the challenge is, and you all have to gear up to this challenge to get these things done. And I think we can all do it because we have so many hands, we have so many professors, and we have so many students with us. So make use of everybody and everything at your hand to get this job done. The job has to be done. At the same time, I would suggest that don't stop your research also. That is the bread and butter of this project. Some places funding is here and there, available, not available, this has not come, that has not come. In a network of 100 professors and students and so many things, little bit here and there it could happen. But I think that should not deter you from, carrying out your research and activities. That must go on. Your brain work must go on. That is not stopped. That cannot be stopped by anything. That only can be stopped by you only. You can think of doing something simulation. You can think of something else till the time the equipment is available, till the time funding is available. But don't stop your brain work. That is the most important part of this network. If you want a bigger funding, bigger chunk of funding next year or later, a year later, about a couple of years later, you have to demonstrate that we are doing best. There is nothing like we are doing better than one institute or two institute. There is nothing like it. We are doing the best, and that's not second to anybody. You cannot say that, oh, we are after IISc or we are after this, and no, don't take pride in doing that, saying that. Take pride in saying that we are the best. We also can be best in all these cases. So don't limit yourself thinking wise also, working wise also. Push yourself hard. All the equipment have come, they must be installed. Ensure that everything comes and the equipment is installed, and you give us certificates that it is running well. So this is a very interesting and important project for all of us. It's a great learning for us also. For us, this is a big challenge that coordinating and working with a lot of professors, students, institutions, but none of them can afford to stop their research work. None of them can afford to stop their teaching. Everything has to continue. You have to put more and more time and still continue all other things. There is no concession for doing administration work. Even I do teaching. I take undergraduate courses. I teach undergraduate courses. I take tests. I set question paper. I prepare in spite of whatever. So don't give concessions to yourself, saying that, oh, I'm doing this, so okay, I can do bad here, or I don't do this. No, there is nothing like it. You have to do everything, and that is where the learning lies. If you don't do now, you will never get opportunity later on in life. Over. The project is over, then we are all gone. So if you want to make it a permanent fixture, a few things which are not covered here is defense projects. I say one more direction which has not been mentioned here is that the DRDO, or the government's Indian defense organization, requires lot of materials, lot of healthcare devices for soldiers. Possible for funding is possible in that direction. I will suggest that Professor Palani can give a lecture on DRDO projects, because he is coordinating this project. He's coordinating. I am the chairman of panel, but he's coordinating the entire panel and all the projects which are coming to the panel. Something like that. But I think some engineering person should talk about research methodology, because that is where I think a basic understanding that how to do a research, how to do innovative research is more important. Maybe I'll give a 1 hour talk somewhere and do a good quality research. I think one another thing which is remaining is product development. Professor Trivedi from School of Innovation, product design and development. I think if Professor Trivedi can a lot. I see technology translation Palani is talking about, but
Yeah, we have some options.
we can put it. Yeah, Professor Trivedi, you can call. So all the best and fight. We should be number one. I am again saying we should be number one, no second. Okay. Thank you. All the best.
Provoking address. Your insights truly sets the vision for this workshop.
As our project director, Professor Datta has already outlined the roadmap of the workshop. So now we move to a significant segment of the program, focusing on the SAKSHAM project through brief addresses on its thematic areas. The project are Advanced Materials, led by Professor Sailesh Kundalwal, Healthcare and Medical Technologies, led by Professor Hemchandra Jha. Now I would like to invite Jha sir to give a brief introduction about the theme and the SAKSHAM project. He is leading the theme Environmental Sustainability and Energy.
Okay. Respected Director Sir, Professor Virup Datta, Professor Sailesh Kundalwal, and Professor. So I will start where Director Sir gave us a message that, we should understand that we are the best. I'll just take 1 minute. I remember the day yesterday. I put a message in the night in our WhatsApp group. Somewhere there in that it was really we were the best. When Director Sir sat in Bangalore with all of us, morning 10 a.m. to 1 a.m. he told मुझे सारे slides ठीक करना है, and we were all sitting down. He sat with us 4 hours continuously, and we started from the hotel to IIT Bangalore, Indian Academy of Science, and believe me, the panel was so tough. We had 1 hour. The presentation was started by Director Sir, and then we took one by one. And I should congratulate. So I'll just repeat one thing. SAKSHAM is scientific advancement in knowledge of sustainability, healthcare, and materials. And we had short forms like, the EAC, what we normally call is an energy technology for a greener future. So when we started, we had kept some of the projects, but as we go on, we find these 6 coming up very fast. Biochar in agriculture, energy storage solutions using intermittent renewable sources, and sustainable chemical transformation. So the projects have already started. We have 36 projects in under the Green Fist or EAC, and I feel that these 6 are really turning up good. When I coming to the major equipments, the solid state NMR 500 MHz and the liquid state NMR 400 MHz in Devi Ahilya Vishwavidyalaya is already tendered. The tenders have opened, but we have yesterday night, me and Professor Avirup had received the final quote from Bruca because there was a negotiation. The country head was invited here because the budget is still a bit higher. They quote around 11 crores for this equipments, particle size analyzer. The financial bid has been open. The spin coating unit, the electric probe station has been already delivered to NIT Kurukshetra. The vendor has requested for supply extension about 22nd February, and which we have been accepted by discussion with NIT Kurukshetra authority. The 3 equipments in RTMNU Nagpur, gel documentation system, 10 reaction vessel system, and horizontal techno bid is opened. Financial bid is just going to open after the signatures are done from both the sides. The particle size analyzer financial bid has opened. We'll release the PO immediately. We have analytical PHPLC with 3 others to be installed in different places, which is handled by HMT, and I think Professor Haim can announce that. About recruitment of JRFs under EAC, in Devi Ahilya Vishwavidyalaya, there is 12 JRFs already recruited and joined. In Samrat Vikramaditya University, 6 have joined. NIT Kurukshetra has not yet come up with the advertisement, so we are awaiting from them. At TMNU, 3 JRFs have been recruited and they've started their work. In Bundelkhand University, 1 JRF has already started, and I'd be happy to say that under this theme, 5 of the JRFs have already started their initial training to have at IIT Indore. So we are now handling one by one the minor equipments and softwares. Individual sanction letters have been already given to project wise. The contingency part of majority of the spokes institutions are already framed out and they will be used for the instrument to make the instruments rooms ready. There are many achievements and publications on pipeline. I would not like to announce that, but till now I would like to highlight only one point. Under project under EAC is going very high, and Sriram Raghavendran, director of biochar under the Daji's Institute, which is called the Kana Shantivanam and Heartfulness Institute in Hyderabad. He had visited us and he has a detailed meeting with in presence of Professor Pratosh and Professor Yamini of DAVB and our PD, Avirup Datta, who plan to take up this project in very high standards. Thank you. I think.
Thank you, sir, for outlining the vision and scope of the theme and sharing the encouraging development of SAKSHAM project. Now, moving to the next theme, that is advanced material, which focuses on the development of next generation materials with application across engineering, technology, and industry. I request Professor Shailesh as I. Kundarwal to kindly address the gathering on this theme.
Yeah, so good morning, all of you. When I was invited, actually, I did not know it is a talk, but I presented something for you in case of advanced materials. So let me allow to go in the direction of to achieving the objectives and motives, whatever we have proposed in case of advanced material. Okay. Yeah, so what is advanced material? Actually, see, whenever we deliberately or we intentionally tailor or modify some of the properties from the which can come from conventional materials, then what we can achieve the superior or very unique properties. And these can be used to develop some of the very interesting technologies or some product and development. Then in that sense, via advanced material, what can
This
be
meeting
achieved?
is being transcribed and summarized.
So what can be achieved in this case? So engineered or tailored properties. So this indicate it can be a mechanical, electrical, or all other properties. Then structure property engineering at different scales. So any material, their properties varies from nanometer to micro scale and then again macro scale. Multifunctionality. Nowadays, only engineering materials are not good enough to develop very advanced application. For example, you develop any sensor, so which can sense a deformation and can provide a signal, that is called multifunctional. At the same time, a product or a application is providing a different outcomes, right? Then performance under extreme or specialized conditions. Now high temperature application we can talk about, or high fatigue strength materials, so that involves. So majority of the classes of advanced materials are nanomaterials, 1D, 2D, 3D. Now just note that whenever the dimension of any material reduces below 100 nanometer, then the dramatic changes in its multifunctional properties occur, because as soon as the dimension of any material goes down, the volume reduces by L cube, but surface area decreases by L square. So the surface effect comes into picture. And then there are some smart and functional materials, advanced structural materials. So composite is one of the best example, where we are mixing matrix material and fiber, and then we are achieving some other or different properties as per our requirement. Then energy and electronic materials, biomaterials, and soft materials. Incidentally, all these major classes we are covering under PAIR. So our theme is advanced material theme that intends to develop efficient, cost-effective functional models for multifarious applications. So what we did, you can see the functional materials are divided in 4 categories. And under each category, then these are the applications we have mentioned. And you can see some of the applications are very common: sensors, biosensors, hydrogen storage, and smart structure. Now see, here it completely bridges the science, engineering, and the developed product can go to industry, right? So why it is so? Because we are the network of around 60 to 65 faculty members for these 7 institutions of the whole network. Second, it also aligns with strategic sectors as mentioned here. And as Professor Joshi has covered recently, the one of the most important expected outcome of ANRF pair is innovation and translational potential, right? So that needs to happen from this whole pair project. Now this is the overall hub and spoke schematic, and you can see, so we have again divided the whole project in 6 objectives, and these 6 objectives will be led by 6 team leaders, right? And every team consists of the multiple faculty members from multiple spokes with multiple discipline background. So that's why this science and engineering comes into picture. So these are the achievements and outcomes of advanced material theme till date. So 25 papers came out of these with proper pair acknowledgement. In some of the cases, the faculty from spoke as well as hub, both of them, they are involved as co-author. And in some of the papers, only the one party, either spoke or hub, is involved. Then we have submitted 2 joint proposals, both spoke and by the hub. And most importantly, to achieve the outcomes, whatever Professor Joshi and Professor Datta has suggested, so we are planning to create 5 central facilities, okay, throughout India at 5 institutions. So first facility is multifunctional sensors and hydrogen storage, that will be at IIT Indore, and the name of equipments are mentioned here. Then second facility at Vikram University, that is in the area of biosensors. Then third is at DAVV, and so on. So also you can note that whatever equipments are listed here, so which are fulfilling the requirement of these central facilities, and which these facilities can be used not only for the network, but these will be available for all faculties which are belonging to the pair network. So in that way, we need to maximize the outcomes, and we are always need to go ahead with the technology development. Now just again, I am moving towards this advanced material. So graphene, most of you know this. So it is a single layer of carbon atoms where 6 atoms are arranged in hexagonal packing array. And the innovators of this graphene, they have received the Nobel Prize. And this comment by the Nobel Prize committee, it is shown here. So you can see there are very interesting properties can be seen at nanoscale level. Now why it is so? Because graphene, it is a material, it is made up from graphite or carbon fiber. So the right hand section shows the carbon fiber, cross section of carbon fiber, and then multi-layers of graphene are shown, and then carbon nanotube. Now you can see the bulk material or conventional material is showing very what you can say lower properties in terms. So these properties are involved electrical properties, mechanical properties. But on the other hand, the carbon nanotube or graphene made up of from the same bulk material, they show very interesting or higher properties. So in that way, the properties can be engineered. And one of the example, or I can give you some, yeah, sorry. So now why these nanostructures show very higher elastic properties? So what is the reason? Actually, whenever we are breaking down any material at nanoscale level, then the chances of having voids or inhomogeneities decreases, right? For example, in this case, now the rope, steel rope and the steel bar, they are made up of from the same material. But one material is very strong. Those are those who are from civil engineering nowadays, that pre-stressed column or beams, they are using ropes because it is 5 times greater than that. Its elastic properties are 5 times greater than that of steel bar, and also it can bend. Okay, apart from carrying tension load. So you can see the metallic plate made up of some material and the steel wire made up of from the same material. There is a huge difference between the strength of these two materials, right? So what happens whenever we are bringing down any material at nanoscale level, the chances of having inhomogeneities, impurities, voids are getting decreased, and then these properties show very enhanced mechanical properties, right? Now second is those who are from mechanical engineering, they know this bending relation, right? So 1 divided by E is a Young's modulus, D is a diameter, right? So whenever diameter of any fiber or any material goes down, the bending stiffness or flexibility increases drastically, right? The third is the whenever the dimension of any material goes down, the surface area of these fibers or these materials increases. So what happens whenever we embed these fibers inside the polymer matrix or any metal matrix or another types of polymers, then the load transfer characteristics of this composite can be increased drastically. Now see how we can engineering the material. So this is a graphene, and it is well known fact that the graphene are non-piezoelectric, means we cannot get any polarization out of it. But in fact, there are 20 non-centrosymmetric groups out of 32 symmetric groups which can be made piezoelectric. How? So the polarization vector, that relation is shown here. It is a summation of both piezoelectric component and flexoelectric component. But when polarization is absent in the material, the polarization can be generated via breaking its inversion symmetry. So in this graphene, we created some non-centrosymmetric pore, and whenever we apply the load, so what happens, this graphene is made up of carbon atoms and air. At the interface of the pore, strain gradient is getting generated, and because of strain gradient, the flexoelectric effect comes into picture. That is nothing but the polarization, right? Now another type of strategy can be a bending of graphene. So what happens, out of plane bonds are pi bond and in plane bonds are sigma bond. So these out of plane bonds, they are becoming asymmetric, and because of that the dipoles are getting generated. So this is what called engineering of these nanomaterials. In that way, the also in case of multifunctional sensors, so that we plan to develop here at IIT Indore, you can see different types of sensors are there, and accordingly we plan to develop prototypes out of it. Okay. So yeah, so piezoresistive CNT based sensors. By the way, this 301B, it is not the name of these sensors, it is the name of my lab. Actually, it is the address of my lab, 301B. And this technology already we are developing there. So you can visit during the period of your this 5 days stay at IIT Indore, and you can see how we are doing this. So in the first, the CNTs are in agglomerated form whenever we are looking at bulk level, and it is very challenging to break them apart, right? Because of higher surface forces, they are tending to become agglomerate, right? So then we are using some dual ultra mixer, as well as recently we got this thinky mixer. Then we can prepare a homogenized mixture of CNTs and polymer. In the second step, we are using spin coater to develop these thin films. In the third, we are putting it that inside the oven, and accordingly this facility electrode deposition actually at NIT Kurukshetra and IIIT Bhopal, under the pair we are delivering this RFDC magnetron sputtering machine. At NIT Kurukshetra we are delivering this lithography and all other major equipment. And the last stage is the testing of these sensors. So we are having electrometer, DC3 meter, as well as source meter. So this is a complete package, and you can visit, you can see how we are developing these sensors, and in fact you can test these sensors. Okay. Now next is how we can use this advanced material with some other applications. So hydrogen storage, a lot of push is there from the central agencies or government of India. So basically there are two types of storage mechanism. First is physical, second is material based. So metal hydrides, it is well known, but in this case what happens, there is no reversibility, means whatever hydrogen you are storing, there is no scope to use 100% out of it, because the absorption is the main mechanism in case of hydrogen storage in metal hydrides. That's why chemical reaction happens between hydrogen and metal hydrides, right? So whenever we are taking out hydrogen out of it, so 100% is not coming out. Also, uh, you know, hydrogen may get contaminated in case of metal hydrides. On the other hand, the physical systems where we are compressing hydrogen gas or liquefying hydrogen gas, in that case 40% of energy we are using to compress it or to make it uh, uh, in liquid state. Now what we are proposing, there is another way to store the hydrogen via physisorption mechanism on nanostructure. So physisorption mechanism means with the help of adsorption, these hydrogen molecules or these hydrogen atoms will be bonded on the nanostructure. And why it is so important, now you can see at the beginning we have carried out some MD simulations, and you can see the right topmost diagram. After applying some pressure, the hydrogen molecules are bonded over the graphene area, right? And then we did some parametric study. So you can see when the length of this graphene we are increasing, after a particular point we are unable to store more hydrogen. Let's say 20 nanometer by 20 nanometer area. If that graphene becomes so much of area, then you can see the hydrogen storage becomes stabilized, you cannot store. So what it indicates, so we can use the graphene oxide or graphene powder to store this hydrogen storage. So this agglomeration and all other issues we can resolve. But not only MD simulation, also we are carrying out some experimental analysis that I am going to show. Now see what is called reversibility. So you can see there are three plots, adsorption for 3 pressure range, and then desorption. So adsorption means whenever we are storing the gas and whenever we are releasing it, so it follows the same curve, right? So there is no loss of hydrogen gas. Also it is fully reversible. So we have compared our results with these existing results. So you can see at 350 bar, only 2.1 kg of hydrogen can be stored in 52 liter tank. Type 4 tank, that is made up of composite and it is a high strength tank, then it becomes double almost at 2 times of pressure range. But if we use nano powder of this graphene, then 4 kg of hydrogen can be stored at 100 bar. So you do not need so much of energy to store this hydrogen. Also it is very safe at 100 bar, because whenever there will be a chance of failure of these cylinders, then the damage or the destruction because of such explosion will be less, because we are using less. But not only experimental, not only the computational, we are also developing these aerogels inside our lab. So what we are doing, we are mixing this graphene oxide, and based on that we are preparing this hydrogel, and now we are in the testing phase. So those who are related to sensors or hydrogen storage or advanced materials related research, please do visit this 301B lab. during the period of 5 years, you can discuss with me, because at this stage we need to move very quickly, because in upcoming months all equipments will be available for us, and accordingly we need to proceed, right? Yeah, so these are the concluding remarks. Okay, so dream project, that is advanced material theme, provides a rare and timely opportunity to create interdisciplinary national research landscape at 6 spoke universities. So the prime objective of this pair is to boost research capacity of this spoke institution. That is the prime. And also not only that, but the long-term and sustainable multi-institutional research collaboration can be carried forward beyond 5 years via joint external grants from other funding agencies, joint guidance, joint technology development, and startup, and so on. With this, I would like to finish my talk, and thank you. Yeah. So I can take 1 or 2 questions if anybody is having. Okay, thank you. Yeah. Paint.
Thank you, sir, for your valuable insights and highlighting the importance and potential of advanced materials. Next is the theme of healthcare and medical technologies, which emphasize innovation in medical solutions, healthcare delivery, and technologies aimed at improving human health and well being. I request Professor Jha to kindly address the gathering on this theme.
So thank you, Nopreet, and respected faculty member on DICE, of the DICE, colleagues, students, and faculties from the spoke. So as the name suggests, HMT, Health and Medical Technology, this is the one of the vertical in SAKSHAM what we got. So here we have one of the very recent or emerging topic, that is AMR, antimicrobial resistance. And either you are working in the health domain or not, I hope all of us are hearing these every day. And it is kind of one of the, you can say, the havoc also, because there is no actual data or factual data available. Everyone, every town or every hospital have their own stories. And being in the Asia or and at least Southeast Asia, we are one of the most vulnerable group for this. And it seems that after the post-COVID, the way we took self-medication, and still it is going on, and the way our healthcare chain is associated with the society as well as the hospitals. This is something rampant of growing. Whatever the figure of 10 years ago, it has hugely changed in the last 5 year, and then now it's going on. So to with that consideration, ICMR or Government of India last year they declared in India also AMR years. So basically they are trying to push and emphasize more and more people aware, as well as to get something either early diagnosis or the prevention as well as the therapeutic about it. Because as we know now, world is not anymore that truly globalization era, right? It is like local. If you have your own solutions, you are fine. Otherwise, you have to be dependent on someone else, and they will victimize you. And that's how going on. So to make all these possibilities, we propose that AMR, although not much, we can say people were working it earlier, but some of the people, 5-6 people from out of 24 hub from IIT Indore, as well as the similarly approximately 30 outside the IIT Indore were involved. And then we came out a very nice and very focused plan for that. So myself and Dr. Professor Sarad Gupta and Dr. Hitendra Kumar, we all, and after that also all 24 hub faculty, they are working tirelessly, that I'm going to show you how last few months, as well as getting help of Spoke University also all the time. Also, we have the SPAs, very wonderful SPAs, either sitting in the R&D or working in the our departments. They are really very good. So the in half faculty, me, then Sarad Gupta, Professor Dr. Hitendra Kumar, Dr. Parimalkar, Professor Avinash Sonawane, Dr. Professor Prashant Kodgire, Professor Amit Kumar, Professor Abhijit Joshi, Professor Lokesh, and Professor Saurabh Chanda. These are, and Professor Mirza S. Beg. They are from the core bioscience and biomedical engineering, although they all are not biologists. Some of them are physicists also, some of them are working in the robotics area as well, some of them working on the sound, ultrasound, some of them working in the, some of them are like pharmacy background, some of them are chemistry background. So various backgrounds, it's like truly interdisciplinary. Then we also have Professor M. Tanveer, Professor Apurva Das, Professor Saibal Mukherjee, Professor Venkatesh, and Professor Dinakaran, and Professor Chandresh Moria, or so on, from the hub faculties. Yeah, like Professor Rajnish Mishra, Professor Surya Prakash, Dr. Vijay Lakshmi, Professor Abhishek Srivastava, Professor Chandresh Moria, Dr. Dan Setaraj, and Professor Abhirup Datta also. They all are the team members total in our HMT, and they are various background. It is needed because we all know that health compartment is very, you can say, the complicated. Only getting either engineer or either chemist or either biologist or either one clinician may not solve this complicated problem. As the directors have just said, that the era where we have to develop some kind of technology, we can get some society related problems, we need to have a multiple collaboration and multiple people, their background, and then only we can think about to solve these problems. So some more detail about the center wise, like we have the total 29 project. Triple IT Bhopal we have 2, NIT Kurukshetra we have 10, Bundelkhand University we have 4, DAVV we have 10, and Bundelkhand and Barkatullah Bikram University, sorry, VU is Bikram University 4, and Bundelkhand University 3. And these are some of the project name where the PI from spoke, as well as the hub, it is here. And then we are divided in the experimental, that is could be the computational one, or the theoretical one, or therapeutic one, or the preventive one. So we can see here the cluster like diagnostic, therapeutic, and prevention. So these two projects are in the diagnostic, because early diagnostic or stage-wise diagnostic are also important. So they are here the engineering faculty from the Triple IT Bhopal, where they are collaborating with our hub faculty, and then possibly going work for the diagnostic field. And then some of the major equipment there, like fiber optic based Raman system, FPGA boards, high-end workstation software, with for that electronic workstation, rapid prototype facility. These are all the needed equipment that may be very helpful, that is going to be actually very helpful, not for only for the Triple IT Bhopal, for the other spoke and hub faculty also. So whatever the facility we are here saying, it is as Dean R&D as well as directors have said, that it is going to establish within 2 to 3 months maximum. So everything is going to start. So you all need to talk to them also. It is not like that whatever right now spoke and hub we have, we can have the multiple collaboration inside this umbrella as well. And then yeah, I'm not going to detail in the primary outcomes, but yes, there are a lot of AI ML based stuff that can be seen from this Triple IT Bhopal projects. And then further we have the NIT Kurukshetra. Again, here we are having the 10 project, and then PIs from the various department, biomedical, mathematics, electrical engineering, and mechanical engineering from the NIT Kurukshetra, and same from the our hub part also, like here mechanical engineering, biosciences, and the computer sciences, mathematics from the hub side. And then project wise, you can see in cluster therapy, diagnostic, all are listed here. And then also we have the prevention, diagnostic, and computational therapeutics. And these are some of the equipment at NIT Kurukshetra we are going to establish, like high-end workstation, quantity real-time PCR, again license of for the software, electrochemical analyzer and testing modules, optical profilometer, EEG headband, high-end optical microscope, And then a very unique setup, tissue culture and molecular biology facility. We are going to establish 4 places. One of them is the NIT Kurukshetra, where almost all basic facility of the cell and molecular biology lab is going to develop for at least for next 5 years. And this is a tremendous job, because here almost altogether we have 75 instruments, like somewhere 15, somewhere 20, in that manner. So this is also going to establish there. So basically, not only the high-end equipment, we have the actual day-to-day usage laboratory also, that is we are going to establish, and SPLC system. As Professor Sharkar said, that SPLC we are purchasing 4, one of them for IIT Indore and 3 of them for other different institutes. Similarly, like optical profilometer, we are purchasing 5 total. One is for IIT Indore, 4 other for the other spokes. So these all tenders and these stuff gone in that manner. And then here, these are some of the other in the tissue molecular biology lab, like qPCR, HPLC, optical profilometer, and which projects they are going to align it. But beyond that also, we can work on it. Now, DABB also has the 10 project, and domain, you can say therapeutic and prevention and therapy, and all spectrum of the or faculty spectrum of the IIT Indore, as well as the DV, like either from the life sciences or biotechnology or computer sciences or pharmacy. All spoke faculty are involved from DABB, as well as from the IIT Indore also. And some of the facilities, as we just mentioned, like a microplate reader and the life ledger, cell molecular biology lab, again for 60 lakh, peptide synthesizer, very unique, we don't have right now in anywhere in this area, confocal microscopy, ultracentrifuge, and so on. Altogether 4.1 CR only from the HMT at the DABB. And now at Bundelkhand University, also we have 3 projects with the pharmacy and biosciences and biomedical biotechnology. And there also we had UV-VC spectrophotometer, high-end workstation, cell molecular biology lab, HPLC sonicator. So basically, it is catering a wide range of interdisciplinary. And again, it is not only for the spoke. Our hub students also, if something is not available here or something is not working and queue is very long, they can book it. The all system will be online, and then they can use it. And it vice versa for the spoke facility also. Possibly for the NIT Kurukshetra, they can go to the Bundelkhand University, or Bundelkhand University, they can go to the DAVB. They can come to the DAVB, something like that. So these all information and log sheet will be available online from our SAKSHAM team. And now the Vikram University, there also we have 4 project from the, again, pharmacy and bioscience and biomedical engineering group. And there also we have a imaging microscope facility, cell molecular biology lab. Yeah. So with that, our all instrumentation is there. And as we just said, that 3 main theme is here. One is the prevention, second is the diagnostic, third is the therapeutic, all 3 domains. And when we have the data, as we are knowing now, whatever the data set available, that is mostly not for the India, or you can say Southeast Asia. So generation of the data is also important. That one thing is missing in most of the time when we are talking about the prevention or AI-based software. So if we are training our, you can say the models based on the European data or based on the Western country data, most of the time they are not going to work with our population or our hospital sample. So one thing we all should understand, that we put some effort to get or generate the data set for our community also. And as this AMR, that is very much, you can say, associated with the genomics as well as the multiomics or the races of the Indian ethnicity. So if we are simply jumping on to have hypothesize some kind of model without our own data, it may not have that much usage. Definitely it has a uses, but it not have that much usage. So my humble request to all spoke as well as the hub faculty also, so we need to work in the kind of umbrella project. That's why in the HMT, most of the project are having multiple hub faculty also, because someone from the one-to-one, it may not be fruitful. It is completely, you can say, kind of impossible to get really something translational. So we have to understand that. hair cell culture is also important, your data analysis is also important. At the same time, making the new therapy for the pharmacy or the chemistry is also important, right? And then understanding through the biophysical instrumentation very quickly, that is also, characterization is also same important. So just getting that kind of vibes. So whatever listed right now, you may not have to restrict only that only, you can go beyond that also, because the aim is, as just Professor Joshi said, now in India we need to make something for India, and then it will go for the globalization it also. So the AMR that is really needed for our country, we don't have much data at the ICMR or the government level, we need to create it. And believe me, this is the kind of first project where 28 project has been given in one go in the country for the AMR. That is not a small. IIT Indore, and similarly 30 faculty from the outside the IIT Indore, they are working in the one domain. That is not, and then we are creating this facility everywhere, right? And all kind. Also, we have our own facility from the something from earlier also. So this is a unique combination right now, and great opportunity for us. We should not miss this bus, and definitely after within the 2 years or something, we should have some kind of a benchmark where they can believe us, and then we can deliver something for the next phase of the project in this domain. Thank you. Thank you very much.
Thank you, sir, for highlighting the importance and potential of HMT theme and sharing the details of faculty members and projects of this theme. Now I request Dr. Pratyush Bansal from DABB University to share his views. Welcome, sir.
Thank you very much. I was not prepared for the presentation because was not any. So really, that was a nice experience and opportunity for us in the DAVV to work with the IIT Indore. We are the full as per the objective of the project. We are also learning a lot of things with you. We received a total grant of 25 crores rupees around, and in which 31 projects are being carried out. The project, and all these are in interdisciplinary manner. We have around 26 JRFs are approved, in which out of which 22 have been identified and selected. 13 crores of equipments are going to come. So it's a long way to go, and we are also expecting high with the project. And I'll request Team IIT to be cooperative as you are till date, and also in the future. At the same time, also a detection tool, if possible, then you just provide the Turnitin, if because you are using the Turnitin, and we don't have access to Turnitin at this moment in our university, though we are having the one under one nation one subscription, and the show Suddhi we are using other tool, but what we feel that Turnitin is the better software, and we request IIT Indore to provide the Turnitin to all our PIs from on your behalf. Thank you very much.
Thank you so much, sir. This is time for a short tea break, but before that, I request all the dignitaries and
This session focuses on key aspects of effective scientific writing, including structuring manuscript, presenting research outcome clearly, and aligning submission with the expectations of high quality journals. It also aims to provide practical guidance on improving the visibility, clarity, and impact of scientific research.
We are privileged to have with us our first speaker, Professor Debayan Sarkar. Professor Sarkar is the Professor of Chemistry at Indian Institute of Technology, Indore, and currently also heads the Center for Rural Development at NIT Rourkela. He completed his MSc in Organic Chemistry from University of North Bengal and earned his PhD in Organic Synthesis from the Indian Association for the Cultivation of Sciences, Kolkata. Professor Sarkar has held several prestigious international research positions, including postdoctoral research at Stanford University and visiting fellowship appointment in Japan and Germany. A recipient of numerous national and international honors, including IIT Indore Best Research Award 2024, ChemCom Pioneering Investigation, Asymmetric Reactions, Economic Synthesis, and Natural Product Synthesis. Professor Sarkar has published over 60 research papers, holds 2 patents, and has successfully guided several doctoral scholars, and many are currently pursuing research under his supervision. As a mark of appreciation and respect, I request Professor Datta to kindly present a bouquet to Professor Sarkar. I request Professor Debayan Sarkar to kindly take the session further.
A very good morning to all of you. And, so this is what is the picture of the pod building. And I come from a lab which is called Sustainable Transformations, and where we mainly do catalysis and sustainable chemical transformations. But today I have been bestowed with to give you some inputs on principles. This is something that we have been doing for all the years, but whatever I have assembled today in the slides is something based on my own experiences. Okay, and I'll start with like this. So the first question I often tell my students is that what are the processes in which we want to get our work published? The first thing, what we call, is a journal publishing processes, and it starts often with 7 days, goes to 1 year or more than that. So if you see the divisions, I think the first thing would be writing a paper, referring and dealing with referee reports, and then I'll come up with some rules of success. Okay, that's my own perception. It can differ. The first thing is that, see, deciding whether to publish. So I tell always in my students, first thing which is important in research is, what is the question? Okay, so your questions should be right. That's very, very important. If you have a right question, then you should target to get a right answer. So why to publish? The first thing what you need to ask yourself as a researcher, it can be any of these three to see your name in the print. Okay, so you need to choose that which one is most important for you. The next question what I ask, or we should ask ourselves before we decide whether to publish, is, have I got something worth publishing? Does the work add enough to existing knowledge? Is it of interest to others in the field? So please let me know if you have any questions. There can be a lot of interactions. Okay, before planning to go for something to publish, Does the work add enough to existing knowledge? And there's a point where you need to look into the literature very, very well. So this I point because I feel that sometimes we get very hurried in our research. To my co-workers, to sufficient time to be given to have a complete literature survey, what I feel. Because if you just start working in a project and if you realize that all the attempts have been already done or something has been already done, competitive, we should all agree in today's day when we're talking about AI, every project is competitive. So I tell you, like, I come from a chemistry background. I will not teach you chemistry because it's a general audience. But in chemistry, what happens, we think of a lot of intermediates, a lot of intermediates. For example, it can be a radical, it can be cation, anion, what is this? See, getting the right question is very, very important. This is my first point of research. You should understand when to publish, is there enough content, and what is the question. You should be confident before taking any attempts to go for publication. So I think that the question, and it should be very, very vital, going to the very inner understanding that is my question correct. Next portion is, or next point where we should believe on is deciding where to publish. It can be a conference proceedings, it can be book chapters, journals, and when it comes to journals, it's very big because 26,000 journals available throughout the globe in different subjects. Your work can be interdisciplinary, but whether the work shoots to a particular journal or not, this is very important. How to choose. See, when it comes to how to choose, I feel that this can be some points. It can be deliberable, but I feel that the strategies should be the topic and the journal coverage. So we should check the journal website very nicely before deciding the publication. Is it peer reviewed? You can find a lot of journals which is not peer reviewed. So where we decide to put it up. What would be the most appropriate readership of your work? That decides. And the last three is something which comes to your mind immediately. That is the prestige of the journal. Length of the time for submission to publication. I'll tell you that many of our friends try to publish in nature journals, but we should be aware that in nature journals, it takes 6 months to 1 year peer review before it comes to publication. So the length of time from submission to publication. One of my German professors told me that in the last summer when I was in Germany, that I will never publish in nature journals. It took 9 months. It is unbearable. So the length of time of submission to publication is very important. The red point, what I have highlighted is maybe we consider the highest, that is impact. But again, it is debatable because what I believe is that if your work is superb, anyone will pick up from any journal and read it and cite it. So although we say that it's highest impact, it doesn't matter. I'll tell you, in chemistry, there is a paper called Korres-Jakobsky reagent. That is the most cited chemistry paper in chemistry till now. And it is published in a journal called Synthetic Communication, which has an impact of around 1.2. Okay, because that is utilized everywhere. That chemistry is used in industry and academia. So it's debatable. What do we actually mean by impact? Okay, it's the number we consider. I'll show you how the number is calculated. But we consider it most. But we should ask ourselves and convince ourselves that even if your work is published in a small impact factor journal, if it's worthy, it will be taken up. Now, what are impact factors? I'll tell you that often it is seen as as business terms and nothing else. So we are researchers. Why it is business terms? Because there are some abbreviations attached to impact factors. An impact factor attempts to provide a measure of how frequently papers published in a journal are cited in scientific literature. For example, calculated as an average number of times an article published in the journal in previous 2 years has been cited in all scientific literature in the current year. So if there were an average of 1,000 citations in 2026 for 100 articles published in a journal in 2024 and 2025, the impact factor would be 10. Okay, so this is the calculation. Most journals across all fields have impact factors below 2. Journals with higher impact factors like 4 tend to be regarded as a high impact factor journal, and those above 10 are stellar, what we consider in the scientific community. The next important point as a researcher, as a student of science, I feel that we should keep a track of impact factors when you really want a high impact factor journal. That is how this is being played. Okay, 2006 and 2026, I've tried to record some of them. You can try others. So in JACS, which is considered to be a very, very high impact factor journal in chemistry, it was 7.7 in 2006, and it's 15.7. Whereas Langmuir is also considered to be a very good journal in chemistry, but in the last 20 years, the impact factor has not changed. But that doesn't mean that Langmuir doesn't publish good papers. They publish fantastic papers. Okay. Nanolators, very less change. It has decreased. It was 10 in 2006. It's 9.1 in 2026. But the decrease doesn't mean that nanolators' impact has gone down. No, not it is. It publishes fantastic papers. Okay. For science, it was 30, and now it is 47.3. Okay. So you can have your own judgments on this. So be aware of the core journals in your field. So we should be aware of our core journals in our field. And where do your most highly respected peers publish? See, this is all about competition, what I feel. When we are handling so big project, a lot of publications coming out from different organizations, togetherly we go ahead. We should also understand the projects we take up, the papers we publish. We should be informed about our competitors in the field, because that's a pathway. Now, often I have seen, we have been meeting many editors in conferences, in workshops. So the first question comes, how are editors? So you are a person who submitted as a researcher. So what the next thing comes is when the paper comes for an initial review to the editor. That is the point where the editor decides to send the paper for review. What is going on in editor's mind? That is very important. So all of the editors, when we discussed, we feel that they look into these things. Definitely quality. Good science. Is it well planned, well executed study? The next important point, what I find when we discuss, is a good presentation. The second point we often don't look at as researchers, and I would like to suggest all of you to inform your co-workers that whenever I have discussed with editors, the second point seemed very important to all of them, who said that I look for supporting information, or the significance and the originality in the supporting information. At least they do in chemistry and sustainability, because I have met 2-3 editors and discussed. So supporting information. We always concentrate on the manuscript. It's not like that. An editor simultaneously looks into the supporting information very, very nicely. So they have very important tools with them. They can understand the data and the originality with them within a second. And that should be, although we talk about AI, but not in all fields. For example, if we put anything, any AI generated data in experimental chemistry, it gets rejected because they pick it up immediately the moment you submit the paper online. The next is the scope of the journal. See, we cannot publish anything anywhere. Okay, you cannot publish a food chemistry journal if your work is on a food preservation. Although there is some chemistry into it, you cannot put it in a hardcore chemistry journal. That's going to return back anyway. So we should understand that what is the scope of journal? Does it demonstrate a broad interest to the readership? Okay, so we have to take care of the broad interest of the readership. See, we are submitting the paper to a journal, and they will always try to hold their readership. Each volume matters to them. Okay, will it cite? So the editors will ask themselves and also to you that will your work going to create citations or not? We have to understand that. The last point, except the well-written story, was one of the editors told me that I look into author's enthusiasm in writing the paper. I want to find some words in the manuscript where I find that author is enthusiastic or not. So the degree of the author enthusiasm matters a lot in creating good papers. So I've just shown some pictures. This is one of the paper in our lab, which is we are preparing the manuscript. What I want to show you is that when you are creating supporting information, we should show clear pictures. Pictures taken very clearly. So you see two pictures, left hand side and right hand side. One, the left hand side picture shows a light glowing. The right hand side shows there is no light glow, but it clearly shows the apparatus we are using it. So please try to understand that you should put pictures not only in manuscript, but also in your supporting information, because that gives clarity to the editor, okay, that this work is original and the author is not hiding anything to the editor. Okay. The next question is, when do I have enough for a paper? So this slide is very important, I feel. Outline helps you determine when you have a complete story to tell or what data is to be needed to complete it. Need to be able to support conclusions with data. All issues need to be resolved but not to be addressed. See, a paper doesn't mean that everything you have to address it. It's not that. You should have an outline. You should not wait for all the addresses to be, all the questions to be addressed, and then you plan for putting the paper. This is going to be too late. That should not be the way of writing papers. So we should try to develop the outline as soon as we feel that the story is developing. Okay. So if you see that when we start writing the paper, we should have a strong introduction which will engage the reader. We should try to type in a way that keeps a constant engagement of the reader, I feel. Set the scene, explain why the work is important, and state the aim of the study. I've seen papers from my students which write 2-page introduction in a paper. So this should not be the way. We should have a clear logically organized, complete methods. The question is that for a full paper, I need 2 pages or I need 8 pages. 2 pages is fine. There's no need for 8 pages. It should be clear, logically organized, and complete methods, because if I am an editor of a journal, I will see that if it's clearly logical, or rather, I will count the papers. So, as an editor, if you are an editor also, you will think that I am not here to count the papers, number of pages in a publication, what the author has submitted. It should be clear. So, the results should be clear and concise. Avoid repetition of text, tables, and figures. So we all review papers and we get annoyed when we find that same type, when you see table number 1, table number 2, table number 3, similar information, similar figures. That's not required. So all tables and figures should be clear, concise, and indifferent from each other. There should be relevant discussions with your co-workers. Start strongly where aims achieved. That should be very, very important. Discuss the significance and implication of results amongst your workers, co-workers, before you start all this process. Sorry. I show you one example from chemistry, So if you see this, someone in the, it's a benzene ring, and it's aromatic ring. Someone has put a hand here and they have given a title. It's a very high impact factor journal called Angry Chemie. But this is what is a concept proposal. So he shows a concept when he is writing an abstract, okay? But the concept doesn't end up in publishing Angry Chemie until he shows reality. These salts or these chemicals kept in the small petri dishes is the reality in the body of paper. So you can show something, a concept in a manuscript, but if you don't show any reality in the paper itself, in the body of the paper, not the conclusion. So the outlines can be different types: data, organization, analysis. So you can decide that how an outline can be designed in your own field. But the last line what I have written is very, very important. For an editor, your papers can be a message that it's going to end up to a larger research plan. Just don't put a full stop in the conclusion. You will see that papers cite like this in conclusion that we have shown this particular synthesis, asymmetric catalysis, sustainable catalysis is being carried out in our laboratories in the last line. Why they write it? They write it because they want to be viewed as a segment of a larger research perspective that creates an impact. Okay, so we should not put a full stop in the conclusion. Rather, we should give a view that it's going to be a larger view on the research part. So when do I prepare an outline? At the start of the project. Track a science in your laboratory, and it's the start of the project, you should prepare the outline of the paper. Do not wait until the project is finished or you're safe. So, yeah, I think that's something,
This meeting is being transcribed and summarized.
Okay. Why? But why? Yeah. I'll come to that. Yeah. So do not wait until the project is finished. I often quarrel with my students, My students delay to write papers. I don't tell them to finish the paper, but I tell them only to start the writing, because the writing is important the day you crack the project. And also, I think making weekend presentation, PowerPoints, not to show anyone, but to keep a track of your own progress is very important, okay, because that helps at the end to write a good paper. So this is try to give a clear story of historical perspective and where your work stands. So you can see that there's some chemistry showing 1902, 1985, 2002, 2010 like this. So I think high impact factor papers like this very much. So there should be a historical okay, that helps, that not only helps you to keep your work in a better place, but also to the reviewers the moment when the reviewers have your paper. Particularly, see, one thing you have to understand, everyone has a shortage of time. So it's more the way you present should, if it gives an historical perspective of your work, that makes the judgment easier. Okay. Thesis versus papers. This is for students. See, I feel your thesis is a kitchen sink. Okay. Your papers should be jewels. Okay. So don't compare with thesis with the papers. Revise and refine and do it again till you resubmit, okay, or submit it. So it's a continuous. So journals publishing processes: submission, reject; referring, reject; revision, reject; revision, more revision, reject; and then acceptance, and then publication. So we should be habituated with this. Okay? So it's with everyone. It's with you, it's me, with everyone in this world. Okay? So this will continue. This is fine. We should accept it. Why? Why we should accept it? As a chemist, I'll show you these two opinions by two great guys. The first one is Thomas Jefferson. The next one is known to everyone, Linus Pauling. Paper quality. Why? This paper goes to some guy who will judge your paper, and he actually is fighting with two things: paper quality and his extreme emotions with the paper. So, and emotions vary. For example, the guy up, he says about chemistry, if you are obliged to neglect anything, let it be your chemistry. It is the least useful and least amusing to country gentlemen for all the ordinary branches of science. Okay, so it doesn't like chemistry. Whereas Linus Pauling says, I feel sorry for people who don't know anything about chemistry. They are missing an important source of happiness. Okay, so we have to deal with different guys, as reviewers. Okay, that's okay. Now, okay, I'll just show you. Yeah. Now, referees reports after you get the paper back. What you want to see, what does the author see is marked in blue, and what does the editor see is marked in red. If you see the author, as a myself, if I submit a paper, I would like to see the reviewer report as experimentally and theoretically excellent, reliable data, no flaws. Whereas the editor sees suffering from serious flaws. Okay. Ratings overall same, but overall assessment comes reject in present form, but encourage submission of new manuscript. This is somehow good. Okay, right? So the thing is that I want to convince you all that after writing the paper, the way we see and the way the editor sees can be totally different, and we should accept it with more enthusiasm. This part is important for us. Responding to referees' reports. Read the editor's letter first for instruction. Keep a deep breath. Okay, I do it. Whenever I receive a review in the morning, I open my mobile, I say review. Take a deep breath before proceeding to the reports. I think it should happen with all of you. Okay, the moment I see the decision, I take a deep breath. Get ready myself for the next thing too. So you should take a deep breath proceeding for the reports. If it's not good, put them aside for a day or 2 or a week. It's okay. It's not going to change. So it's fine. So we should take a deep breath and put them aside for a day or 2 or a week. Reread reports, discuss with co-authors, revise the paper, and prepare the response document. Remember, even comments that seem aggressive or ignorant can be helpful. I have found it. Okay. So nothing to be getting angry. My students come and say, सर ये रिव्यू जो है ना इसके पास गया होगा इसने रिजेक्ट किया है and the same and I'm telling you the same thing for German. We got one paper by one of my students, Sangeeta Vishi, and we had a German colleague in this paper, and that paper rejected 7 times, and that went to a guy who is a competitor of the German guy. We understood that, but it's okay. But he gave some aggressive comments, but that helped us to make the paper better. Okay. Always view this is as a chance to improve the paper. Okay. Good response to referees' reports are well organized, use a quote and response. A numbering system of points is very important. Provide full explanations. Do not overlook to ignore any points. Be polite. Okay. This is very important. So you should have the comment, response, comment, response, comment, response. I know it often feels boring, but we should provide full explanations of comment, response, and we should be assertive and polite. The decision. The editor will make a final decision based on how well the referee reports have been dealt with, revised with care. The other things we know, I just want to make the last point. Make the editor's job as easy as possible. Because we should understand that he deals more than 500 papers a month. So make his work easy as possible. Clear signs lead to high citations. This is one work. So we have tried to follow some of this. Dr. Majid is sitting here. This is a recent paper last year in ACS catalysis from our group. And if you try to follow this, we had very, very aggressive comments in some time. And this paper got cited by Professor Benjamin Lest, who is a Nobel laureate in chemistry. So if you follow, if you be an assertive, take time to respond, take a deep breath. I think that clear science explanation leads to high citations. Okay. Thank you, and thank you, Abhirup, and the entire NRF SAKSHAM team. This is my old, new groups. I'm thankful to all the funding agencies. I wanted to show this photograph. Particularly, we are missing this guy. It's Professor Sharad. And this is the team which presented in ISC Bangalore. You can see all of the spoke institution leaders and everyone here during the presentation. This is the picture just after we came out of the C.V. Raman Hall delivering the presentation. We were happy, faces were good. And Sharad is smiling, our director is also smiling, and all people were there. So we have this is that picture. And these are some others. So I think that we are together going towards a very nice direction. We can make a difference. Okay. I want to end my talk with these 2 photographs. I feel that the first photo has changed the world. Okay. It shows the need of sustainability and research. And the right-hand side by none other than Marie Curie, who we all know, and she says, science without humanity is blind. Humanity without science is lame. This is my present group. I think this group is smaller. It's, I think, two years back. I'm thankful to the Department of Chemistry, IIT Indore as a whole, instrument and facilities, and everyone in the group, my group members, they do a good job for me. Dr. Majid and Dr. Harsha is also here maybe. So they all help me, and whatever I present in front of all of you is the thing that what they work. With that, thanks a lot for listening, and if you have any questions, I can answer if there is time. Okay. So if any questions, you can. Yeah. Yeah. First shot is, I'll say that you should go for high impact factor. But again, if it doesn't get accepted, as I told, that we cannot judge the editors and we cannot judge the reviewers with whom it's going. So if it is it doesn't get accepted, we should not waste time, and we should put the paper in any journal, because that will pick up citations, I think, and your next work is that will be helpful for that, I feel. Yes, I think, as I told you, that we should try to have the first submission in Q1, and then it's better that if we judge the comments, because the reviewer comments give us a good understanding that where the paper is standing, and that is a point that where there should be a concise decision among the group leader and the group workers, particularly the paper authors, together sitting down and then taking a plan that shall we try any more Q1 journal? Is it required? Because I think the first review is very, very important. If what I take is, I can tell you that if I feel that the Q1, the reviewer comments are harsh, and this work cannot make up to a high level Q1, I'll definitely go for Q2 and Q3, because time is very important. Yeah. Yeah. Ma'am. Mm-hmm. Yeah. Yeah, that's true. That we should not wait. I'll say you, but is the concise, because what happens, we work with co-workers, and our co-workers have some expectations that they also want to get it published in a good journal, and that we need to make a concise, consensus decision. I'll say that where Q1 nahi jayega hame lag raha hai, let's put it in Q2 and then proceed to the next work. That's better. Particularly people who are starting these careers, they should not waste time, yeah, in just waiting for 6 months to submit. That should not be done. Yeah. Yeah. Okay, conflict of interests normally doesn't arise. If it arises, then it's better that we disclose it during the paper submission. There can be, different type of conflicts of interest. For example, the conflicts of interest may arise that who is going to be the first author, or who is going to be the main supervising author. I think in all these cases, whenever it arose, my answer was very simple, and I was to give a star mark on all the. True. Are dealing with papers, and the normal question comes that if he had a sufficient contribution, why we have not added in the first beginning. Normally, this type of situation, if they arise after the first revision comes, then they have understood. So, but in that case, if you write to the editor in a good way, or if write and try to explain the roles already played, that may help. But in majority of cases, they don't allow. That's true. We cannot do it. Yeah. 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 I think, ma'am, this will be varying subject to subject. First thing is this. For example, in chemistry, if you are not a theoretical person and they sense a little bit of AI in any of the papers, irrespective of the variety of chemistry we do, organic, inorganic, physical, whatever, environmental, whatever, they are going to reject it in the good journals. Okay. You want to say that they are doing the review by AI? Ah, okay. Okay. Well, it's a very tough question to answer, but I will request the editors or the reviewers. I'm not sure they're giving these papers to co-workers or not, and they may use it or but this is totally against the journal policies. Yeah, but they often write back to the reviewers. Your review contains AI and Chat GPT. Then I asked my student that can you just have a look into that, but she told me that no, sir, we don't find something like this. I don't like this is going to be a common wording maybe कि यूज कोई जो यूज नहीं कर रहा है उसको भी कुछ लिखने के लिए वो लिख रहे हैं क्या उसमें भी थोड़ा वैलिडेट करना पड़ेगा बिकॉज it has become so unmatchable कि कौन सा AI है और कौन सा AI नहीं है that's is something questionable okay okay what is that so that's the reason that where you need to have a solid literature survey of the latest work in your competitors. I'll not say that it is publishable or not. That is not a question. The question is that is your work relevant to the time when you want to publish? Because if you often see that's not taken up. It's not that a lot of articles have been published. It's not on that particular work. But maybe the subject as a whole has moved to a different direction. You can see that I feel strongly in my own field that maybe 5 years back, what I wanted to chemically synthesize, and I have not been able to do that. It's not that many things have been published. But if you see, in 5 years down the line, I feel that the approach towards particular science has changed. So I think that today we talk about, in chemistry, we talk about sustainable pathways. For example, we try to use light. We don't want, people are saying that it should be there in your, publications. It should follow that science. They never say that maybe you wanted to make that drug. You don't make this drug. It's not that. So they say the pathway should be different. The pathway should be new. It's not the target we're talking about. It's that timely approach of the way the science progresses. That is very important. That's a worldwide competition. Okay, what I feel. Okay. Because, I'll add you, we were targeting an anti-cancer molecule. And a molecule which acts as a chemical synthesis with a different chemical synthesis what our Norwegian collaborators were making. And we started this 2 years back, but no one is interested now not to make the molecule. They want to make the molecule, but they are saying that it should be enzymes, it should be light. So no one is talking about a chemical synthesis anymore. So we should understand the way the science migrates in a totally new direction. In a particular therapy 20 years back, we know we need it today also. But we cannot use a lot of chemical synthesis to get it anymore. So it's rather not the target, but the journey or the pathway to reach the target is important to me now. What I feel is. Okay. I think. Okay. Thank you very much. And thank you for listening.
Thank you, sir, for this extremely informative and engaging session. The guidance shared today will certainly be valuable to all the participants in streamlining their scientific writing and publication efforts. So now we'll be taking a lunch break, and after that, the next technical session will be starting at 2 p.m. sharp. So I request to all of you to gather here by 1:50, so that at least we all are seated before the speaker arrives. And we'll be moving towards the Chittit Mandapam for lunch. Chittit Mandapam. Photo. Before we move ahead to the next technical session of the day, this session addresses a highly relevant and impactful theme: industry academia collaboration through technology translation. It emphasizes the importance of collaborative efforts in translating academic research into scalable and sustainable technologies.
Before we begin, I would like to briefly introduce our esteemed speaker, Professor I.A. Palani. He is working as a professor in Department of Mechanical Engineering at IIT Indore. He completed his PhD from IIT Madras and carried out postdoctoral research at Kyushu University, Japan. He has established the Mechanotronics and Instrumentation Laboratory at IIT Indore, and his research expertise include laser-assisted surface processing, micromachining, smart materials, and shape memory alloys. Professor Palani has published over 185 research papers, filed 18 Indian patents, and has successfully executed sponsored projects worth over rupees 15 crores from agencies such as DST, SERB, DRDO, DAD, and JSPS. He has also worked closely with leading industries including Volvo Eicher, John Deere, and Webco, and has strong international research collaborations across Germany, Japan, South Korea, Russia, and USA. He has held several important leadership roles at IIT Indore and is currently serving as the project director of IITI Drishti CPS Foundation under National Mission on Interdisciplinary Cyber Physical Systems. He is also a recipient of several prestigious awards, including the IEI Eminent Engineer Award 2025. May I now request Dr. Dan to kindly present a floral bouquet to our esteemed speaker as token of appreciation. Talk. Welcome, sir.
Hope my screen is visible and I am audible, right? Okay. So thank you very much for the nice introduction. So I have been associated with this institute for almost close to 15 years. So this particular talk, almost like it shares some of my experience with an industry. So as far as we academia is concerned, normally like we have a kind of whenever we are trying to interact with industry, we have two issues. One is industry normally used to ask us a proof of concept, okay, but on vice versa, we ask the industry to fund the proof of concept, right? So this is where exactly the major hindrance come to interact with the industry. So like for this particular aspect, so I would like to. Okay. Hello. Right? Okay, so people in online mode, okay. For this particular aspect, so there is a need to understand overall methodology of a technology and how a technology can be like scaled in a particular aspect and how it can be transformed to the next level. So for this, on an academia perspective point of view, these are some of the keywords. I think nowadays you might be hearing a lot about it. So in fact, like 30 years before, 30, 40 years before, as a faculty, our main motto was towards teaching. In fact, I remember like some of the engineering mechanics which was taught by my professor is still in my eyes. Okay, where the focus of research was not that to a level for a faculty. So most of the researches were performed by an undergraduate or a postgraduate student. Sometimes they have few PhD scholars who will be working on it. However, nowadays we have transformed ourselves to take this startup culture. So either as an academician, we should be involved in a startup, or we should be having a capability to leverage the startup for our students. So in those particular aspects, like when I try to look into the overall architecture or the overall resources which are there for an academic perspective point of view, one is of course the intellectual property right. So as far as IPR is concerned, like most of the academicians are aware about an IPR. So when do you go for an IPR? Or when do you feel that I should go for patenting this particular technology or patenting this particular idea? Okay. So you feel that if the particular technology has a commercial value, you try to go for patenting. Okay. So apart from that, now I will just ask you one question. I'm pretty sure madam will not object towards that. So you as a faculty and as a student, you are trying to file an IPR. Now the IPR belongs to the student or the faculty or to the institute? It is an institute. Okay. Because the institute gives a grounds to develop it. So whatever technology is there, the technology is leveraged from the institute to the next level. Now we are the part of the custodian who will be handling this particular technology. Now in that particular aspect, like there is a kind of a sharing part, especially with reference to revenue perspective point of view, you have a certain sharing which will be taking part with reference to this intellectual property. Second, with reference to manpower perspective point of view, most of us work with undergraduates and postgraduate students. See, like when you take any kind of technical problem, so PhD students has a certain amount of leverage towards a particular technical problem. Like for example, PhDs have a capability to do a wide or a kind of a deep literature survey of that particular problem. So we may need to utilize that particular characteristics to address a problem. Second, with reference to master student or an undergraduate perspective point of view, in the case of a master student, they have a capability to model it or they have a capability to build an experimental setup because their foundation is strong enough in their undergraduate level so that they can take up the product to the next level. So ideally, like if you want to develop a proof of concept, utilizing an undergraduate student or utilizing a postgraduate student will be much helpful. How about an undergraduate student? So undergraduate student always has an advantage because the reason is they are in the verge of getting their fundamentals. So they have a capability to question the fundamentals. In fact, that is what we call it as out of box thinking. So in fact, like I used to closely work with most of the undergraduate students because they have a capability to go for an innovative product because for them, they don't need to worry about any kind of scientific rules or any kind of scientific fundamentals. So whatever there on the table, they would like to assemble it and they would like to make it as a product. In fact, like almost in our early childhood days or when we see our kids, they make a building block. They make lot of different combinations. Finally, they come up with a final product. Okay. So this is through an experience which is not bound by any kind of rules. So that is one advantage you go with an undergraduate student. So always whenever you are trying to come up with a technology, it is always good to start with an undergraduate student. Next, with reference to sponsored project and consultancy, we will discuss about it in detail. Now, the second parameter which I would like to discuss about is a TRL level. So what do you mean by a TRL? Have you heard about this word? Okay, so it is called as a technology readiness level. Of course, this is a kind of a scale through which normally we try to fix up the proof of concept or the product scale. As far as this particular scale is concerned, this particular scale is not defined by us. It is ideally defined by NASA. So that is the reason if you see there are in the TRL 9, you could see some kind of flight trials are included in this. Okay, but we took this as a standard and of course we have taken it up to the next level to finalize the scale. Now, with reference to academic perspective point of view, let us consider this TRL 1. So this TRL1 basically talks about the basic principle or the reporting. So that is what normally even in today in ARRF also, if you see, whenever you are submitting a project proposal, they used to emphasize on the conceptual note. So conceptual note is nothing but a 2-page write-up which will give you a kind of an understanding about the particular project. So which you can express your views about the particular project. In fact, this TRL1 basically talks about that. So where if you can bring up your idea in the form of a paper, so that it will be helpful for you to leverage this technology to the next level. Next is TRL2 talks about the technology concept or the application. Basically here, whatever you are trying to develop, it should have a orient towards a particular application. So based on the application, it has its own relevance. Like for example, if I am developing a small drone, so I cannot generalize this drone. However, I can orient this drone for a particular application. So appropriately, the testings are involved as well as the different design aspects are also involved in it. Next, we have the TRL level 3, which basically talks about the analytical and the experimental functions, especially with reference to the proof of concept. So where what we try to do is, like as I had mentioned about a drone, so we may need to theoretically analyze its behavior, and then we may need to come up with a kind of a small experimental setup for establishing this proof of concept. So this is where exactly TRL3 tries to lie. Next, we have a TRL4. So this TRL4 talks about a breadboard validation in a laboratory. So when you try to consider a laboratory environment, or when you are trying to establish a laboratory for this particular drone or some other applications, normally we have our own constraint. One constraint is with reference to funding. Second constraint is with reference to creating an actual environment where you are planning to test the system. So this is where exactly, so we try to set up a breadboard so that we can simulate the conditions. In fact, people who have worked on materials, you might have heard about this accelerated corrosion tester. So accelerated corrosion tester is almost similar to this, where you are setting up a certain amount of boundary. With reference to the boundary, you are trying to check your system. Next is with reference to TRL5 perspective point of view or the TRL6 perspective point of view. It is more to do with a kind of a, you are trying to fit up your limitations and boundary conditions, and you try to simulate the actual environment of where exactly you would like to apply. So you will be testing your final product within this range of TRL5 to TRL6, and the TRL7, as I had mentioned, it is something like checking the proof of concept in the actual environment. So we can have a certain amount of commercial test beds which are there. So with reference to this commercial test beds, we can check the system. Next, TRL8 and 9 are more towards the commercial value of it, so that you take up this technology to the industry, and then the industry will be performing certain amount of certifications or ethical clearance for its final validation. So in any case, if you see, starting from the lab to the land ecosystem, it will falls within this particular region. In fact, I would like to address in this forum, Dr. Archana Chaudhary has prepared on software so that there are some certain questionnaires are there. So where when you try to input the questionnaires, you can automatically identify where is your technology. So it is at which TRL level. So ideally, commercially, there are no systems are there. Normally, it is done through a techno-commercial experts. You are demonstrating that? In the okay. Now, as far as academia is concerned, we normally fit our overall research in these three boundaries. So one is, of course, a kind of a pure research, where what you try to do is the major outcome comes in terms of the publication. Second, research is more focused towards a kind of a basic research. It's a kind of an extended research. And then we always talk about the final product coming into it. Okay, just to give you a kind of an overview, this will give you a clarity. Whenever we try to talk about a kind of an ecosystem in the institute, especially with reference to research perspective point of view, the outcome is correlated with reference to the TRL level. So some people will be interested in the fundamental research. So fundamental research means you will be cracking down some of the key theories or some of the key theorems, focusing on a high quality publications. Basically, it's a kind of we will be bringing out some of the innovations, and we will be proposing some of the innovations, and through these innovations, we will be striking down the cutting edge research. Next, when you try to talk about some of the sponsored research, basically from DST or from DRDO, so we try to attack the problems basically on a lab scale. So you start with the conceptual, you try to reach to the TR level 1 to 3. Third, you have a kind of an industry research. So as far as industry research is concerned, like it is something like addressing a key problem statement. Like for example, some problem used to come to the laboratory based on your expertise, where you may need to address it. Already it is on the TRL level 1 to 2, which you are trying to leverage it and take it to the actual standard. Sometime it might be towards implementation, or sometime it might be towards the final application of the system. And the last is towards product oriented research. So this is where exactly like in nowadays, you might have find some calls where they say that they want an industry on board. The reason is already you have certain amount of technology in your kitty, and through this you are trying to leverage it to a final product, ideally in the range of TRL 3 to 6. Okay, in fact, like recently there is a call is there, ARTRI from ANRF, where they look for like industry contribution, and the mandate is the project should start from TRL 4. From TRL 4, you can leverage it to the higher TRL level. Now, as far as for creating this particular ecosystem, you need to have a proper infrastructure on an institute perspective point of view. That is like we faculties, it is very difficult for us to do marketing. In fact, most of us are, I would say very less faculties go for a LinkedIn profile. In fact, we don't update our resume also regularly. Okay, so we need to have a kind of an expert pool, basically who understand our strength and convert the strength in the form of a marketing. So this is where exactly we have our own like technology translation system, where you have a people with a corporate bent of mind who will take up the positive points and who try to leverage these positive points to the next level. So ideally, like if you want your technology to go to the market, it should have a kind of a branding. Like let me just give you an example. I'm not sure how many of you have seen this RIN advertisement. In most of these RIN advertisement, the concerned person will be wearing either white or blue. So that is because that is what the marketing strategy is. So which, of course, on an academic perspective point of view, we are pretty poor in that. So you require a kind of a expert who can help us in translating it to the next level. Okay. So where you have a techno-commercial expert in place. Second important point which an academician normally faces is, like for example, an industry is coming to you and asking you to submit a proposal for their consultancy project. Giving a value to it itself will take a lot of time. Sometimes we may underestimate, sometimes we may overestimate. Okay, so what happens is, if you are going for an underestimated like quotation, you are at a loss. Okay, if you are going for overestimated quotation, the company will say, no, I am not going to look into it. Okay, so evaluation of this particular, like in fact, like quoting for a particular problem statement itself is, it should have an appropriate justification, which sometime on a faculty level we may do, or we may require a techno-commercial expert to help us to prepare a quotation for it. Okay, in fact, the quotation sometime it depends upon the scale of the utilization of this particular technology. Okay, in fact, I will give you a small case study which we had done. Okay, and then you should have a pool of like IP experts and then the postdoctoral fellows who will be working with you to take up this technology to the next level. So ideally, it might be either a spin-off or a technology translation. So any questions on this? So I think I had discussed two important points. One is a TRL and other one is a ecosystem in an academia.
As an academic, it's going very nicely. As an academician, it's really confusing whether my technology, whatever I develop, it is in 2 level or 4 level. So how we can bifurcate this? Exactly how we can differentiate? 1 and 2 easily.
Okay.
But 2, 3, 4 is little bit confusing in laboratory level. So
Okay. Madam, may I know your expertise?
yeah, I am working in solid state devices, mostly fuel cell. I am working the material for fuel cell, cathode, anode, and electrolyte.
Okay, okay.
And I fabricate, but as compared to market product, my efficiency is little bit less.
Okay.
It's not compatible.
Okay,
So
okay.
how I can identify that in what level my technology reach?
Okay. See, if you can test your technology in the laboratory scale. Okay. So for testing your technology on a laboratory scale, you normally rely on 1 or 2 equipments which is within our like economic level. Okay, because for example, if you want to test a system, you can go for a high-end system or you can go for a low-end system. It basically depends upon the funding. Now, based on the testing, so whatever validation you get on the laboratory scale, that is almost at the TRL level 3 and 4. That is, your system is responding to the laboratory scale values. So that is
It is not compared with the commercial.
not required, not required. See, actually, like each and every technology, according to me, has a value. Okay. See, wherever there is a highly sophistication is required, then I go for a high efficiency system. Wherever I go for a low sophistication or a low requirement, I can go for a low efficient system. I don't need to fit a high efficiency system into a low efficient like application. For example, you take today battery is considered to be a major like research. If I don't need to have a high efficient battery for a normal LMV or a two-wheeler. Okay. So if I have a capability for a low efficient battery and if it is fed to a dynamometer, that is sufficient enough for me to handle it. Okay. So based on your application or based on the efficiency, if you can identify an application region that is lies between TRL 3 to TRL 4. Okay. So if you look into this particular process, so your application is almost decided over here. So based on the application, you can just decide your laboratory scale. Okay. So in case if you feel my system is of highly efficient, then appropriately my target will also be a bit high. So this is where exactly, in fact, I will just explain you about a valley of death for a technology. So there are 3 regions are there where we will be talking about how a technology dies after a particular time.
But now we are in TRL 4
Hmm.
and now I want to apply for prototype or commercialization.
So have you filed a patent for this?
Yeah.
Oh, patent is there for this.
So how it is approachable? Because I try to contact with the companies, but they are not understanding what I say. That
Okay.
gap is there.
Okay.
And I can't understand what they expect.
Okay.
So that gap is always there.
True, madam. Actually, this is what we call it as valley of death. Because certain times what happens is the industry what we are approaching might be looking into the like benchmark product. So they might not appreciate the product what we are developing it. But it doesn't mean that we are not reaching a particular point. So there are, so instead of reaching to a higher corporate, normally it's better to go for a spin-off. So that through a spin-off we can take it. That is one way. But still I would advise you that if you can leverage your technology through some packaging. So that currently if the technology is in a kind of a proof of concept and if you can come up with a packaging, then it will be easy for you to demonstrate. Packaging of this particular, see normally like, so this holds good for me also. We start one technology. If I try to pursue the technology for 2-3 years, if there is no welcoming is there, I drop that. Okay, so it will be a patent and then that patent most probably I will be renewing for some time. But after that, then after a particular point, it becomes old and it becomes a kind of a open source kind of thing. Okay.
It's given that 20 years.
15 years is the 20 years is the 20 years. So after that it dies. Okay. So like if you see the efficiency conversion of any institute which converts the technology into a final product, maximum efficiency will not go more than 25%. Any institute if you take, because most of the technologies used to die in the lab or it will be in the form of a reporting. Okay. So that is why like normally to our PhD scholars also we emphasize, we say that you go for idea patent so that within a year you get an idea on it. If the patent gets granted, it is easy for you to go for a publication. So you have publication also in your hand and you have a patent also in hand. Okay, so that patent can go for techno commercialization if it hits, but still you can survive with the publication. Any other questions? So, like, let me just give you some case studies which we had performed. Like one case study is with DRDO. So, I think most of you are aware about DRDO funding, I think so. If not so, DRDO funding has 3 different things. Like we have like Army, Navy and Air Force. Similar to this, they have a different board. So one is a kind of a aero board which talks about aeronautical part. Then you have a naval wing. And for Army, there is an armament research board. Under these boards, you have multiple verticals, like which includes like materials, sensors, Then there is a separate wing for robotics, ultrasonics, etc. Many wings are there. You can apply it appropriately. Most of the time it is a kind of an open call. If there is a taker from any laboratories, then the project normally used to go through. So panel has a power up to 1 crore. In case if you are exceeding more than 1 crore, it goes to a steering committee and then they decide. So it is something like the chairman DRDO has a power up to 50 crore. Beyond that, it goes to the ministry. So this is how the process follows. In case if there is any immediate solution which is required from a DRDO, so there is a scheme called contract acquisition scheme, which we call it as CARS. So where there is a limit of up to 25 lakh, where the concerned lab can give the project to you. But the major catch in this is it's a kind of a consultancy. It's a kind of a service which you are providing. So it can be restricted only for 15 months. And the outcome will be taken back to them directly. It is very difficult to file a patent under that. However, with the board, you can go for any kind of patent. Okay. Now, as far as this particular project is concerned, so we had this thought process called electrostatic charge. Most of you might be aware about this electrostatic charge. So some interest came in that particular domain because the reason is we were just studying this electrostatic charge and we thought that if we can harness this electrostatic charge for some particular application. So as a faculty, I also started with a kind of a conceptual proposal. So I made a 2-page write-up. So the thought process is, if I can integrate this electrostatic charge based generator inside a shoe sole of a soldier, so that when the soldier walks, so automatically the charge can be generated and it can be used for powering up a sensor device. This was a simple conceptual proposal, almost a TRL1. So we submitted to ARDE Pune, so who are dealing with this armament board. Because the reason is we came to know from source that there was a program going on which was called a soldier as a system. That is, you want to reduce the effort of a soldier when he is walking. So appropriately, you have to equip him with some different sensors or the different components. So with this as an idea, so we gave this particular 2-page write-up, so that here, this is a kind of an institution from IIT Indore. So I took this case study from Tokyo Medical Dental University. In fact, we had a kind of a case study how we should approach for a project application. So with that template, so I approached DRDO, and finally we could secure a funding of, like, in fact, this is what is the technology, basically, which we call it as a triboelectric nano generator. So which we demonstrated in the lab and we gave it to the as a 2-page conceptual proposal. Now, so DRDO had several rounds of discussion. Finally, they said that, okay, we will come up with this project under a particular board, and finally we could deliver a final product out of it. So in this particular product, like, it's a kind of a 3 years project where several 2-3 manpowers were involved. We could start the TRL1 product to a TRL6 product, so that as a TRL6 product, it can go to the field and it can go for a testing. Now, if you go through this entire process of it, so we started with TRL1. At TRL2 and 3, we developed our own laboratory test bench. So in this laboratory test bench, so we try to study its behavior, and we also optimize the overall design. In fact, like what we did is, if you want to integrate it inside a shoe sole, so we made a retrofitted sole, so that this retrofitted sole, soldiers doesn't need to use it every time. So as and when they want, they can remove it and they can go for a dummy sole. Second thing is, in certain cases, if they want to switch it off, so there is a provision in place where you can switch it off. Now, in this particular system, this is a kind of a walk to charge technology. Like, when you walk, you can power up any devices. So here we have used 2 devices. One device is a GPS module and another one is a RFID module. Okay. So in this GPS module, you can locate the overall, like, position of a soldier, and in the case of a RFID module, you can identify he is the particular soldier. Because in certain cases, in fact, currently we are deploying some kind of gait analysis also, so that in case if some other soldier would wear these shoes, automatically, because of the change in the gait, the system will shut down. Okay. Now, the story behind this is, so one is with reference to laboratory scale, second is with reference to manpower perspective point of view. This work started with an undergraduate student, in fact, a first-year student. What he did is, he developed a small mat for the laboratory and he connected that mat to an alarm. So whenever when an intruder enters in the night, automatically the alarm switches on. So we were working in a temporary campus where there used to be a power shutdown. So with this system, it was a kind of a seamless power system he has established. That was the first proof of concept which helped us to come up into a final product. Okay, so the take home lesson from this particular technology is, for each and every TRL level leveraging, as an academician, we have a freedom to tune the test beds, because certain test beds, it is very difficult to get it on a, like there are certain test beds which are not available also, but using an undergraduate and a postgraduate student, not only you can develop a product, you can also work on the test beds or tailoring the test beds based on your application. Okay, so this is the take home lesson what we have, and we could deliver 15 pairs of shoes to this AID Pune, and now we are on the second phase. Currently in the second phase, which we will be working with a company called there is a 2-3 shoe companies are there. Through with them, we will be working, and we will be translating the technology to them. Okay, action shoes. Now, next is with reference to this technology licensing perspective point of view. Okay, so as far as technology licensing is concerned, there is a question which comes into your mind. What do you mean by a commercialization, and what do you mean by a technology transfer? Okay, so when do you go for a technology transfer, and when do you go for a technology licensing? Technology transfer normally happens like when you are at a lower TRL level, and if a company is ready to take up this technology, they will leverage it to a market level product, and then they sell it further. So this is where exactly the technology transfer happens. Commercialization perspective point of view, if you have a complete product or a complete solution where you can take it directly to the market. Okay, like for example, you might have heard about this company called Aether. So what does this company does? Electric vehicles. So Aether was a company which was started from IIT Madras. So in fact, like when I was doing my PhD, those students were doing their like master, they were dual degree people. So what they did is, there was a major issue, because at that time getting a motor was very difficult, and that too, thinking of a motor for a hybrid vehicle, especially for electric vehicle, was very difficult. So they were working on designing a motor in such a way that it becomes a kind of a brushless system, and then they started deploying in a small two-wheelers. Now it has become a very big company. In fact, there was a kind of a proper ecosystem which was evolved. From a lab, it went to a IIT Madras Research Park, where they got quite a good amount of funding from the venture capitalists. They could upscale the technology, and now it has reached a market. In fact, IIT Madras also has its own share over there. So here also, in this particular technology, so we had a kind of a interaction with some of the like problem statement. One of the problem statement, like 3D printing, you might be knowing. So most of you are well aware about 3D printers, but most of these 3D printers are restricted for a macro level. There are no 3D printers for developing a sensor. So with that as an idea, we developed this machine. It's a kind of, it's first of its kind which uses thin film as a feedstock. So with this, we could print a certain amount of sensors. In fact, like most of you can go in this particular direction also. We don't have any manufacturers in India to manufacture strain gauges. Okay. In fact, this is one such machine which could print strain gauges for any kind of application. So we started we started giving service to ISRO for 2-3 applications. One was related to piezoresistive sensor and as well as strain gauges. So by seeing its potential, of course, this is a kind of a TRL level 4. So we could transfer this technology to a company, and now we are taking up to the next level. So this is a kind of different devices which was printed on the scale, and some are on a commercial level also. So finally, I have a rights towards the technology, as well as I can also do service to the strategic applications by giving the sensors to the system. Okay. So this is one good example where I have both technology transfer and the commercialization. So on a commercialization perspective point of view, IIT Indore will used to participate in GEM to deliver some of the sensors. However, as a technology transfer perspective point of view, now the technology is transferred to a company so that the product can be developed on a higher level. If you want to print a ceramic on a polymer, it is possible. So like for example, you might have heard about silicon carbide, right? Silicon carbide temperature is close to around 2400 degrees Celsius. It is very difficult to deposit on a PET sheet of 150. However, this structure, this micro heater, is a silicon carbide deposited on a PET, printed on a PET. No, actually I use a thin film. So like in this technology, what we do is we use this concept called laser decal transfer. We make a thin film and then using a laser decal transfer, we transfer this to the flexible substrate. Okay, so it's a kind of a cold printing which we do so that your property of the material doesn't get changed. Okay, so that is the niche technology which we could prepare it in the form of a system. In fact, like for this system, we got funding from DST. 2 level of funding. First level for version 1, second level for version 2. Okay. Yeah, you are free to visit our laboratory. So we have the system in place. So like you can see the system, and in fact you can see the devices also. Yeah, it's a now in fact like we are going to the next level of making it in the form of a commercial system so that it will be deployed in DRDO for printing devices. Okay. Now the third case study which I would like to discuss about some of the industry projects, like how we have addressed some of the industry projects. That is a kind of an immediate solution where you can approach an industry and you can convert it into the kind of a problem solving. Like let me just tell you a story. So I think most of you might have heard about this company called WAPCO. They are famous for this heavy truck industries. Okay, and then there is a company called ZF which now taken up this, and now they are taking up to the next level. Now, as far as this particular company is concerned, they are involved in manufacturing these brake pedals and clutch pedals. Now, what they do is, like for a Mercedes-Benz car, the overall configuration of a brake pedal and clutch pedal will be different. For a Maruti Suzuki, it will be different. So their main motto is to give the service for the brake pedal and clutch pedal. For each and every prototype, they used to invest a lot. So they used to have a die. Within the die, they have to press it and then they have to make it. So for a die cost was costing close around 3 to 4 lakh. So in order to prevent that, so they were looking for a solution. So like since I used to give a talk to different industries, through that this contact came. So we were trying to establish a technology called as die-less manufacturing, so that you don't require a die. You can directly use a laser to bend any kind of structures. With this as a key solution, so what we did is, this was a kind of a small thin sheet. So using a laser, you can bend it and you can make any kind of structure. So your die cost is completely eradicated. You can directly interact with the laser. Now with this, we could approach 2 industries. In fact, one industry was towards brake pedal and clutch pedal. Another industry was taking care of the bracket of this particular truck, which we could bend it using this. Now, the major concern in this is, today in most of the industry, implementing a laser, so they have their own reservations because of its safety. Now with this, we could bring an awareness to the industry. Second thing, this technology is now implemented in the industry, and then they could also form it in a different form. Okay. Now the take home lesson of this particular case study is, with reference to academic perspective point of view, there are quite a good amount of research papers are there in this domain. In fact, it is not only from IIT Indore. In fact, it started with IIT Guwahati in the year 1990s, where there are several research papers are there. But there is a barrier which exists where this niche technology, or I would say this is a kind of a preliminary technology, couldn't reach the industry. That is because one thing is with reference to awareness, second thing is with reference to they are comfortable with their own conventional system. So this is where exactly we academicians have a kind of a role to interact with the industry, so that we have a provision to have a kind of a short-term courses like similar to this. So where we can invite industries and we can give some of the areas where they can pitch in. So that will be helpful for us to connect with the industries and go for a solution-oriented research. So this is one good example which I would like to present over here. Second example is you might have gone to Zudio, and there are several showrooms are there where they used to have this eyeliners and nail polish. So in this, if you see, there will be normally a kind of a marking will be there. So I think I have a marking. This is, if you take these bottles, on these bottles, there will be a printing which will be there. So this printing is a kind of a screen printing. Now, the major concern of this industry is, so I would say in India only one industry is there which caters all this printing. And it's almost a kind of a crore worth of business. So they do it for all the companies, including Lakme and many other agencies, and they give it to the thing. So their main motto is they get the bottles from from a big private player. They do the screen printing, they verify the screen printing, and they have to give it. Remaining product will be filled by their own company. Now, for each and every bottle, they get close to around 10 pies only for the screen printing. And you see per day, close to around 8 lakh bottles used to go out of it. So this is a per day business. Now, one of the major problem statement, this came directly to us because since we were working on automation, they want to have a kind of a like inspection line in this to check whether the printing is proper or not. So like it should be fast enough in such a way that at no time the bottle should not stay at a particular point, not more than a second, and each and every bottle has to be inspected. This is what is the problem statement which was given to us. Now you tell me, so I have given you a kind of a overall rough figure how much it is. How much should I put a quotation for solving this problem? Or what are the parameters should I need to consider to give a quotation for solving this problem? I know the business of the company. I know the problem statement. Okay. So what are the parameters should I need to consider to prepare a quote for this problem?
Size, shape, amount, the word size, amount of whatever the ink from the spring coating.
Spring coating they are going to do. My main motto is I need to develop a technology for inspecting the particular text, whether it is fine or not. If it is fine, then I need to allow that towards the online. If it is not proper, I need to put it in the. I need to check the thing. For example, if it is written Lakme, so that Lakme should be proper. If it is not proper, I should reject the bottle. If it is proper, I should allow the bottle for the next level packaging. That's it.
So quotation should be 10% of the thing which they are charging from the spectrum.
But the material is theirs. Material is theirs. Process is theirs. I am only going to give a solution for them. Or I am going to give a kind of a system which can test it. Okay. In fact, that system also I am not going to give. I'm just going to give them a design. That's it. Yeah, an idea.
But if they are charging 10% per bottle,
Okay. But like
it is getting wasted.
for 1 paisa per bottle means like if it is not proper, then it gets wasted. Okay. So almost I quoted to that level only. Okay. So that here the quotation what I had given is apart from the equipment cost which I am planning to invest, or the technology solution part which I am going to invest. Because to define this technology solution, I need to deploy a manpower, I need to deploy the institute resources, and I need to deploy the consumable cost, because I need to do some trials before taking it to the next level. Consumable cost, I need to deploy a preliminary experimental setup over here. Or in my laboratory, first I will test it, then I will deploy it over there, test it, then I will give the complete code and everything so that then they take it up. Okay. Plus the 1% what you are mentioning. Okay. So this was my overall quotation which I had given to them. So it was close to around 22 to 25 lakh which I told. Okay. Then they said, okay, you can go ahead, but their main constraint is I should implement it within a month. Okay. So the idea what we took is, we took an image processing. So we took a template, a Lakme properly printed template. That image will be taken, and the image when it is in a production line will be taken. We made an algorithm so that this will be checked with the standard template. If it is proper, that bottle will go. If there is a deviation, it will push. Okay. So like now the good part in this is we have implemented this in the production line, and it is a kind of a in situ system. So one more good part I could achieve from this is the student who was working with me was observed in this company for a higher salary. so that is good part of this particular project. Okay. So now some of the conflicting demands from an industry and a faculty is like, of course, as I had mentioned, one is this consulting model is considered to be one of the important points. Second important point is the proof of concept. Okay. So like whenever we are trying to negotiate with an industry, it is always mandatory that for the proof of concept, if they could pitch in at least the salary of the concerned manpower, that will be helpful for us to take it up further. Because you cannot ask the concerned company to give a complete, what I would say, money for this particular proof of concept. However, you can ask the company to bear at least 10 to 15% of the proof of concept cost, so that it gives a kind of a confidence for you to take it up to the next level. Okay, so these are the two important parameters which I would like to say, which is more important. Okay, next is like this question I think I have already addressed, like when we need to go for a licensable product. So as far as licensable product is concerned, once you feel like it is always better to prepare a kind of a TRL level model or a conceptual model, send it to the concerned industry, so that sometime industry may take it or sometime industry may give an input. Okay, so through that we can take it up. In fact, like Dr. Archana will apprise you, we have a very good model over here. What we do is like we try to consolidate our technology every year and we prepare it in the form of a handbook. So this handbook will contain only one page of each and every technology, so that the reader doesn't need to go into it. Second thing is like these are being defined in a different subsections, like either it might be a healthcare domain or it might be an automotive domain, etc., so that it reaches a particular person, and then automatically the industry connect will come into the picture. And in fact, in certain cases, a community connect will also comes into the picture. Like we also came up with this concept called 1 week 1 technology. That is like every week a faculty's technology will be sent to the industry as well as to the newspaper. So what happens is like the faculty will get an understanding about preparing the technology in a fashion in such a way that the common person can understand. Second thing is technically we are pretty clear, so we know how to prepare it for an industry. But if we can have a capability to write this technology in a common platform, that will be helpful to reach. In fact, through this we got quite a good amount of technology translation also. So these are the two good initiatives which we have taken. It has been successful also over here. Okay. Now this is what I was talking about, the valley of death. So don't worry that almost it is not possible for us to convert all the technologies into a kind of a innovation. Based on the risk, your valley of death quantum will get changed. So in fact, like when you are on an academic level, basically on an innovation level, you have a small valley of death. When you are on a translation level, you have a wide, deeper valley of death. Sometimes what happens is the technology will be very good, but it cannot reach the market because of ethical clearance or because of certifications, etc. So there, this kind of translation may fail. And in certain cases, with reference to commercialization perspective point of view also, some products will be very good, but because of lack of marketing, it might not reach. Some products are so, but even without marketing, it may reach. So it basically depends upon the particular time, so when you are marketing it. So this is kind of a generalized statement. So let me just give you some of the like case studies. In fact, these are some good case studies where exactly technology has been translated to an academic level. This Oxyon is a very good technology which they were dealing with textiles, and this basically talks about how technology has reached to the market, and these are the different levels, including like starting from patenting. In fact, it started with 1995, and in 2020 they could reach the market. In the market in the sense that like it can be directly implemented for a particular system. Similarly, this is one service industry where they were also involved in the research project level, and then it could reach the market. So this service industry was for like for a condition monitoring of a kind of a windmill which we had employed. So these are the like outcomes from an academy to the product which it has reached. Okay. And the last one which I would like to give is this is quite an interesting problem statement. In fact, it is from a pharma company, and this case study is quite interesting because it was started by a student, an MSc student, considering as a conceptual proposal, discussed with the faculty, and later it was used for diabetic related applications. It went for different trials. One good advantage of an academic institution is you can do all the animal studies on an academic level. See, like for example, as a company, if I go to an academia or to the hospital for any kind of animal studies, sometimes they don't entertain me because it has a commercial value. However, as an academia, I have a flexibility to go for any kind of animal studies. So with that, the product has reached the market. In all these three cases, I could say that there is one common theme is there. That is, most of the ideas are patented and then it was translated to the final product. So whatever idea you have, whether it reaches the market or it doesn't reaches the market, always it's better to go for a patenting of this particular system. Okay, so okay, madam.
Like in tablet capsule unit dosage form which are there in the market, industry works on that particular thing. When we have our academic research from the nanotechnology perspective, we had every kind of that. We have patented the technology. We had that lab machine where we can go for formulation of nano containing particles on a large scale using that high pressure homogenization technique, which is industrially
Scalable. Yes,
but
yes.
what happens that industry asks for whether the common man can have the afford to buy that particular product. So these nanotechnologies are playing a versatile role. In that case, that become academic research only. My research that is going on for the cancer work, basically all types of cancer. Currently, I'm working on the brain tumor. So fantastic results we are getting in the cell line studies and everything, but they remain that thing only.
Okay.
Because of this academic research, it doesn't go to the
Translational this
because
one.
industry think from tablet capsule dosage form, which is a layman can administer. Self-administration that is possible in that case.
True, true.
So
Actually,
here we are having the 6 or 7 patents I had in this particular line on the same track. When the commercialization concept comes, that time these products gets failed. That research that becomes.
that I agree. Actually, see, like if you see that particular chart what we made, so you require a kind of a techno-commercial pool to take it to the next level. In fact, like now you have raised this point.
Especially in pharma, sir. In pharma, you have required the validated machines, FDA approved labs, all those things only if you have FDA drug administration laboratory approved labs and you have validated equipment, they will have that particular thing.
True, true.
In fact, Zydus Cadila has given us one, this what you are saying, animal studies. Our institute has
Animal studies
this
research.
animal studies. Zydus Cadila, one product was there. They wanted to have that animal studies.
Okay.
We did at our institute.
Okay, okay, good. So actually, like, in fact, in yesterday's, this also you might have seen, yesterday's budget also you might have seen, they are coming up with different iHub, Pharma Hub. So in fact, that is what I was also trying to come. So it is a kind of a global problem where how to translate this technology from the lab to the market. Several universities have attempted this. In fact, like Stanford model is considered to be a strong model. In India also we have IIT Madras Research Park, which is considered to be a very good proved model where they have translated several technology from the lab to the industry. They have invited the industry so that they collaborate with the institute and then they take it up. Okay. So with this as an idea only, if you, I'll just show you this slide. So where this NMICPS came into existence. So this is like, it was a kind of a thought process. In 2020, this call for came where it was more focused towards National Mission for Cyber Physical Systems. So cyber physical system means anything related to IoT or anything related to product development. So there was a need for, on a country level, to develop the manpower, to develop the technology, and to develop a kind of like a hardware portfolio as well as software portfolio, so that you can leverage this technology to the next level. So it acts as a kind of a like centralized hub. So whomsoever is a faculty who has a technology or a startup, they have a technology in the range of TRL 1 to 2, and if they want to leverage it, they can come to this hub and the hub will help in leveraging it. Okay. So in fact, it started with the National Mission for Cyber Physical System. I think soon they are going to start with pharma. That is what in yesterday's like budget it was announced that this iHub Pharma will be introduced everywhere, so that wherever there is a requirement of a technology translation, those hub will act as a base to take up this technology and then they translate it. Okay. In fact, like I'll just give you a small overview how this foundation works. So this is a kind of a Section 8 company. Section 8 company means it has all the flexibility similar to a company. It will have a CEO, they have a CFO and everything. But again, it's a taxpayers' money. So all the rules and regulations will be followed. But you have a flexibility to talk to any person for technology leverage. So like functionality wise, it will act as a company, so that you don't need to follow any kind of bureaucracy. However, with reference to financial perspective point of view, you have to follow all the guidelines of the government of India. So in this particular stage, so one thing is, as a university research, all the proof of concepts will be identified. these hubs will be helpful for translating this product to the next level. So like whatever issues you are facing with reference to technology development, market driven specifications. So ideally, like whatever inputs you want to get it from the market, that can be given to the particular product, prototyping it. Finally, it is more important is the reliability testing, because if you want to take it to the market, one is a certification and another one is its reliability part. So which will be taken care by these hubs, and finally it will be helpful for you for commercialization perspective. In fact, like we have one technology innovation hub. So these are the different cyber physical system verticals, which are it is planted in almost all over India. There are close to around 12 hubs are there. So we are one among hubs. So we are focusing on system simulation, modeling, and visualization. Slowly we started focusing on one important point called this digital healthcare. So that is, you consider human being as a machine, and then you can analyze the predictive analysis and the preventive maintenance of these particular systems. Okay. So all the products were taken and they were leveraged. In fact, the whatever products which you see are from the startup, which was at the lower TRL level, which used to interact with the hub, and all the supports were provided. Now they have reached the market. Okay. Similarly, like there are around 190 research projects are there. So where like it will be taken up, but one good aspect of this is each and every research project is restricted only for 1 year, so that almost every 2 months once there will be a review, and then it will be helpful for you to translate it to the next level. So those hand holdings are done through this hub. Okay. So one hub is there at IIT Indore. You can visit the hub sometime as and when. Okay. So any other questions or any other points? Okay. So Charak DT, suppose you consider a human being. So I can correlate the function of a lung or a function of a lung to a compressor of a machine. So whatever parameter I get from the lung, so if I try to model it for a mechanical system, and suppose if a mechanical if the lung movement is not proper, that data, similar data will be translated into a compressor, and the compressor can be made to kind of accelerated, so that you can predict the overall diseases in the lungs. So it is something like creating a digital twin for a human body, so that it can be helpful for one thing is in case if there is a kind of a herd of disease comes into picture. So this variation in the signal will give us an alarm. So what you're trying to do is you are trying to model each and every component of a human being in the form of a kind of a mechanical model, so that you can input the data and you can predict the failure of it. Yeah, actually so that is why we focus on this data storage, data collection. In fact, there is a huge ethical clearances there. So we work with different aims. Okay, so of course the main model comes over here, but certain data comes from different hospitals, so that it will be validated over here and again it will be tested. Okay, so and actually for example, so the compressor what you're thinking about is a kind of a mechanical system, but in fact the compressor acts as a base for your pacemaker. Okay, so the development of the pacemaker came from a compressor model. Only thing is you change the actuator from the pneumatic to a piezoelectric structure. Okay, so I'm just giving an example so that you can correlate it with a mechanical system and you can model it appropriately. So this modeling is not only for a particular component, it can be modeled for a particular disease also. Okay, and the response of a human being with reference to the disease. So based on that, you create a digital platform and then work on it. So it's on a larger base. Of course, it has multi-folds with reference to the device development. Okay, so shall we close the lecture? In case you have any questions, anyway, I am leaving this article over here. You are free to use it and circulate it. Okay. Sure. What I would suggest is they have a break sometime. No, break in the sense that within this week, they have this entire week, right? Okay. So in between, if you get time, so you let us know. We will make the necessary arrangements to. Yeah, what time you are planning? 12:30 to 2. Okay. Okay, so I would invite you to two lab. One is, of course, my research lab. Another one is the Charak platform, so that you can see that how overall working of it. So probably tomorrow shall we plan for the Charak platform? Okay, so 12:30 we will plan. So Vaibhav from our office will coordinate. Or Vaibhav, Ankit you might be knowing, right? I will inform Ankit. Okay, so I will request one of the doctor to be available. So 2-3 doctors are there who are working with this. So you can visit the center. Okay, so for my laboratory, next day you can let me know. That is over here. So if you're going for lunch, you can visit the lab and come. So Charak Center is near to the workshop. Okay, thank you. Sure. I think online people, we didn't ask any question. Okay, coach.
Thank you very much, sir, for your insightful and intellectually stimulating presentation. Your perspective on strengthening industry academia linkage and enabling effective technology translation have truly enriched this session.
Thank you very much.
Sure, sure, sir. Thank you. Our next speaker will be joining us in a while. किसका किसका लॉगिन नहीं ऑलरेडी? ये इधर भी हिल रहा है पूरा। हम्म। We now proceed to the final technical session of the day, which focuses on another critical theme, that is innovations and intellectual property rights. This session highlights the importance of protecting intellectual outputs and fostering innovation driven research ecosystem.
Before inviting our speaker on stage, I would like to briefly introduce our distinguished speaker, Professor Ruchi Sharma. She is the IPR Chair Professor and faculty member at Economics at the School of Humanities and Social Sciences, IIT Indore, where she leads the Innovation Studies Group. She holds a PhD in Economics from IIT Kanpur, and her research lies at the intersection of innovation, economics, industrial economics, international trade, and intellectual property rights. Professor Sharma has published extensively in reputed international journals, including Research Policy, and has received research funding from agencies like ICSSR, DST, Ministry of Finance, and Ministry of Education. She has played a key role in organizing major international conferences and has served on national level committees related to science, technology, and innovation policies. Her work focuses on understanding how innovation systems function and how policy frameworks influence technology development and diffusion, particularly in developing economies. May I now request Dr. Archana Chaudhary to present a floral bouquet to our esteemed speaker as a mark of appreciation. With this, I invite Professor Ruchi Sharma ma'am to kindly deliver her lecture on innovation and intellectual property rights.
इसको प्रेजेंट करना है क्या उसमें ऑनलाइन है ना हाँ जी स्क्रीनशॉट भी क्यों नहीं जा रहा है स्क्रीनशॉट नहीं जा रहा एक मिनट डाउनलोड किया था तुमने कहाँ डाउनलोड किसी फोल्डर में था ये पीपीटी मोड में नहीं जा रहा ना प्रेजेंटेशन मोड में नहीं जा रहा इनेबल कुछ करना था क्या यहाँ से भी नहीं आ रहा है ना कहीं से भी नहीं आ रहा है भी कर दिया इस पर क्लिक करके देखना प्रेजेंटेशन थी वो बंद कर दिया मैंने अच्छा इसको दोबारा ओपन करना है सेम यूजुअली पता है लेवल एडिटिंग हाँ नहीं वो आया था स्टार्टिंग में मैंने किया था उसको is your slide. एक मिनट रुको, ऐसे ही कर दूं क्या? विजिबल है? इट्स गुड इनफ नो? Somebody has given. So good afternoon, everyone. And first of all, thank you, SAKSHAM team, for inviting me here and give some lecture or introduction and ideas about intellectual property rights to very esteemed guests and participants we have here today. I'm told that you're a part of the PAIR research projects which are ongoing with the IIT Indore. So I'm very glad to be here. The topic I'm going to cover today is innovation and intellectual property rights. And this particular topic is of much relevance for all the participants here because as a part of your research project, you are going to lead to some outcome, right? In academia, we are, a major producers and consumers of intellectual property rights. And that is why we have to be very careful about how we understand intellectual property rights. Why I say this, that as I've been lecturing about IPR related issues in industry, MSMEs, and even in academia, many a times I feel that still a lot of myths prevail, a misunderstanding, and sometimes overlapping of the concept. Sometimes people will speak about copyright and patent in the same breath, where we are very different, right? So, and it is very important for us to understand what do you what do you understand from this term of intellectual property rights, what are the different items which are covered under that, and how it affects our academia and academic life. And moreover, we also have to think about as we progress, and as in suppose we become a leader in our institution and take positions at a higher level, how we can incentivize our faculty members, faculty colleagues, in order to come up with a intellectual property right. So how does the IP policy of an institute should shape up? That is also very important for us to understand. So that is what I'm going to cover. I will briefly talk about the IPR system as an overall, and I understand most of you would also have certain exposure to this term, right? So what I will focus on is maybe clarifying, making some distinctions much more appropriate and much more understandable. And then I will also focus on IP policy for an institution, because having such policies are nowadays being seen as a first step towards translation and commercialization of any technologies which happens in a country. So academic institutions, universities, research organization, why do they need to have this kind of policy is also very important. And then the next step would be, how do they formulate it? How do they design it? What is it that they should take into consideration? And last, once again, I'll come back to you as a researcher in terms of if you are now coming up with creative ideas and, producing an intellectual outcome in a form of prototypes or maybe a copyright protected material, then how can you make money out of it? How do you monetize it? Where does the next step belong? So this is a broad outline about my presentation. I usually start with this particular example, and this very interesting example is a book by Tim Harford, who talks about 50 most important inventions that shape the modern economy. So this modern economy, as we understand, as we are sitting in this particular room, you can see that everything and each and every single item here has been an outcome of innovation of someone, of a company, of an individual, of a maybe a research researchers, when you talk about touch screens, etc. So there is innovation around us in massive way. And the modern economy, as we understand, the modern societies as we understand, has been outcome of this particular innovation revolution, starting from industrial revolution one from last now 400 years. So that is how this particular modern society has been shaped. So that is where Tim Harford now talks about it. And the third one, very interestingly, in that in that book, he talks about the barbed wire. Very surprising, no? As to why barbed wire would be an invention, who considered it as an invention. But at some point of a time, it was an important invention, right? So sometimes you may think it may be a very small thing we are contributing to our research, but you need to rethink how that particular thing is going to shape, your society, maybe the, even your economy over a period of time. The first one he talks about in this book is an agriculture plow, because that is where the revolution and the civilization essentially started with. So this barbed wire, as all of us know, it's like kind of a katili tar, right? We see it like everywhere nowadays whenever a boundary has to be marked. But it was very important in the American context at that point of a time, because there were people who were owning large pieces of land given by the government itself, because they wanted people to use that land. Why would government want people to use land? Because land is a resource, and if it is used, it generates income and employment. It generates output, which leads to income and employment. So resource utilization, they wanted it to happen, but somehow it was not happening, because maybe the wild boars or maybe the animals, livestock from the neighboring field, they were entering and they were affecting the uh, you know people there, on whomsoever was owning that particular piece of land. Now, with this particular invention, what happened? That people started investing in their land. They started owning that particular piece of land. Why? Because now, if you have a plot of land from point A to B to C to D, you can define it. You can stop the entry of the trespassers into that plot. You can invest in it. Maybe you have a tube well, or you do some other, groundwater access technology. If you want to, put there, you can maybe, plant trees which will bear fruits for like maybe next 5 or 10 years. So you started investing in that particular piece of land. So what does this tell us? This tells us that defining of the boundary around an asset which is being owned is very important. Why? Because once you define that particular boundary, the benefit that will accrue from that particular asset will belong to you. It will help in the monetization. It will help in making the profit. Without that boundary, it was very difficult. So this particular example I really like from a two standpoint of view, because first of all, it gives us a bit of a shock, like even a barbed wire can get a patent. And of course, a mass production that happened within 6 years of it being getting a patent is also a kind of an indicator of how important and useful it was as a product, right? So apart from that, it helps us in understanding the need to define boundaries, because once you define boundaries, the asset belongs to you. And this particular case is that of a tangible asset. The exact job of a barbed wire is done by whom? By the intellectual property rights for the intangible asset that you create over your research journey, right? So then this is where the role of intellectual property rights come into picture. Okay, suppose you have taken a very beautiful picture, you came to campus today, and maybe you went for an early morning walk and you click a certain pose, it just come out very beautiful, and you put it on your Instagram or maybe on a Facebook, and somebody maybe like in the next 4 or 5 years takes that picture, and suppose IIT Indore comes up with their own handbook or something, and they put that picture on that particular handbook. Okay, can they do that? No, but it was a very beautiful picture. They found it. Somebody, while doing the search, it was there. They found it and they used it. In an ideal situation, they should not be, provided the intellectual property rights are defined properly. Nowadays, even on a Facebook, you get a notice. If you share somebody's, do you own a copyright to it, or is it? Are you sure it is not a copyrighted material? Or if it is, it will not let it go also. Right? So that is where the defining of the boundaries become very important. Why? Because the moment Facebook tells that you cannot use it without the creator's permission, what will happen? IIT Indore will reach out to you. that we want to use this picture of you, maybe if this is the kind of an amount we would be willing to give, right? Maybe a small amount, doesn't matter. And a citation that this particular picture was taken by this particular person, that really matters, right? So that is how defining the boundaries can help you monetizing even simple clicking a beautiful picture, right? So that is the role of the intellectual property rights when we put them together as a bundle. Now interestingly, humans are very creative, and if they are creative, then that leads to various type of outcomes. It is not that we are ending up producing only one either picture. No. Some people might be writing, they will be doing poetry, somebody will be writing a novel, somebody might come up with a technical solution to a problem which is existing, right? So then the outcome of a human creativity are multiple. As a result, not one single IPR can protect it, and that is why the term intellectual property rights, right? So then what happens? It is a bundle. It is a bundle of different types of rights. Now each right is important in its own sense, and they differ from each other. How do they differ from each other? 4 5 things which is for important to us to remember. First and foremost is the scope. What they cover, they differ in. Okay, so what patent covers is different from what copyright will cover, what industrial design will cover from each other. So you need to know what is the scope of that particular right as such. They will differ in terms of the conditions which has to be fulfilled in order to be given that particular right. They will differ in terms of the legal protection which is given to them. It will differ in terms of the duration for which they are given, right? So these are different parameters on which all of these type of intellectual property rights differ from each other, but at the same time they are put together as a bundle. Why? Because they play a one important role, giving the creator an exclusive right over that particular outcome of their intellectual activity, right? So I hope this particular point is clear. Very much similar to like a barbed wire. Whatever you, the intangible things that you own will now belong to you. And if they belong to you, you will be able to develop a sense of ownership with that, will be able to monetize it and profit from it, right? So I think all of us are clear on this particular aspect, that when we talk about intellectual property rights, there are going to be not one but different types of right, and they are put together because of the common purpose of supporting the inventors and the innovators and the creators, and they differ from each other in terms of what they cover, how long they cover, how they cover, and other terms and conditions which are associated with them. Okay. So any questions so far? I think we. Yes, so that is where the legal procedures for each type of right will also vary. How you apply for patent is different from how you apply for copyright. For example, in copyright, it will belong to you because you've created. And you may not go for a formal registration, but it, in the current context when we are so connected on internet nowadays, it is always suggested that if you have created something, always create a date to it, and if you think it could be useful, then you should go for registration. Yes, because you have created it, there will be a date for that, right? On a camera, you can nowadays very easily say that this is your date, right? If you have already made it for use for anybody, then nobody will be able to copy it. But if you say that, no, this is my copyrighted material, I do not want to use anyone else to use it, it will vary. That's what exactly what I'm saying. It will vary. For example, if you don't go through the process of protection for a patent technical solution, right, then anybody can come and use it, and you do not have any sense of ownership over that. Yeah, when I'm coming to copyright, yes, copyright is not mandated for a formal registration as long as you are able to prove that these belong to you. But as I'm saying, in the current connected world, it's always better to go for registration. If you think that particular, suppose clicked many pictures and you want to upload on a website, may not be a better idea. You can simply say that this is your material and please do not use it without taking prior permission. That's exactly the point that we have to discuss. We have to talk about what is covered in each type of item. right? What will be covered by patents, what will be covered by copyright. So the scope varies, right? What is covered under industrial design, semiconductor integrated circuits, trademark, GI, trade secret. हाँ बताओ. See, so by definition, algorithms are not covered by patent. We will talk about it. Yeah. So if you let me know, I will give you details. Okay. So these are the statutory rules regarding the different types of intellectual property rights. For instance, Copyright Act of India, Patent Act, Trademarks Act, Geographical Indication of Goods, the Design Act, the Semiconductor Integrated Circuit Layout Design Act. So this is why we say these are statutory rights provided by a legal instrument within the country. Two important points regarding these rights. First of all, they are territorial in nature, and then they are negative rights. What do you mean by territorial? As the name suggests, that it will belong to the country in which you have protected those rights. Okay, so if you have protected your invention in, let us say, country like India, then it will be protected here. And if you have not done it in other jurisdiction, then people will be able to imitate it, copy it there. Okay, they will not be able to take patent on it because it will already become a part of the prior art, right? So, and we will see that if you have to take a patent, then there is a patentability criteria. So we'll talk about it. So then they are negative rights in the sense that if you have taken it, for example, you click that picture, doesn't mean that you have to make maybe an album or use that picture in any way, but you can always stop the others from using it, right? So that is why you may keep the invention with you and take a patent on it. It is no longer, it is not important for you to make sure that you use that invention. If you want to go ahead, definitely it will be preferred. However, the law doesn't mandate that you have to use it, right? So but what you can do, you can stop others from using it, and that is where the negative character of this right comes into picture: territorial and negative. So I can largely, if you think from a point of view of academia, these are the three most important IPR which are of significance, that is patents, copyrights, and industrial design. And here first we can talk briefly about patent, as there has been a certain interest in this. So patent is an exclusive right granted for an invention which is a product or a process. So nowadays, earlier there was a time period when in India we could only grant a process patent, but now both product and process patents are allowed in all fields of technology, and it should be something which gives you a new way of doing something or give you a new technical solution to a problem, right? So suppose nowadays we have this bottle, we have water in this bottle. The problem with this water in this bottle is that if I'm drinking it in January, it is very cold, when I must be expecting it to be a bit warm, right? And in the other area, in May, when I want it to be cold, it is going to be very hot, right? So nowadays we have come up with those bottles where we can see the temperature of the water inside the bottle, right? On the top, it can display like that. But what about you come up with certain mechanism which can keep the water warm if it is cold weather, and it can cool the waters if the weather is hot, right? You come up with some mechanism, maybe at the bottom it could be put, or you come up with certain sensor and a material which does the opposite to that, right? So there is a problem, right? Everyone faces that problem. In the cold weather they want warm water, or if not hot at least, and in the hot weather we want cold water. So if it can come up with a solution to that, and you can integrate it with the existing bottle model, that is where we are looking at a technical solution to a problem, right? So, but before a particular item or an invention is given a patent, it is not that it will be given just like that. There will be a proper examination of that, right? So, the first series of examination happens with respect to, in terms of what cannot be patented, right? So, there is in the Indian Patent Act, there is a whole list of items which cannot be patented. So first thing, if you are planning and you're thinking about taking a patent, it is not a bad idea to go through the list, right? So these are only few examples, like discoveries, method of agriculture, like you were just asking, mathematical business method or consumer computer program per se, and a or algorithm. So they cannot be patented. Okay. Now, here the important thing is this term computer program per se. So when they talk about this, there has been a lot of discussion on this particular point, and because India being an IT major hub in the at global scale, so there was a lot of push. But what do you mean by computer program per se? Over a period of a time, the guidelines regarding computer related inventions have become more clear, and more discussion is about the impact of that computer program does. And if you are associating it with certain hardware, then all the best. That is the best solution one can have. Okay. So if you're looking at only computer program per se, then it may not be something which can be patented or an algorithm. Then you would have to seek for what we call as a copyright protection. Okay. So this is the list of the items which cannot be protected. Once you pass through this, what you will find that there is something called a patentability criteria. It is always a good idea to also check your own inventions against those criteria. Three particular steps. First is novelty, next is non-obviousness, and third is industrial capability. So what do you mean by novelty? Novelty, like I was telling you before, if you have taken a patent in India and not taken in other jurisdiction, it will be very difficult for other peoples to take it in other jurisdiction also, because it will become part of the public knowledge, right? So then so any invention is considered as new if it is not anticipated by the prior publication, prior use, or prior public knowledge in India or elsewhere. So it is like a very typical literature review which we do. Yes, we do a prior art search before undertaking any research project. So it is very much like that. So an examiner will check, it will he or she will look at the documents in the academia, they will look at the documents related to patents itself, and then they will see whether it is existing in the current set of the knowledge which is prevalent or not, and that will establish the novelty of your particular invention. And next it would be non-obviousness. It gets a bit difficult to kind of establish, but the basic idea is that it should not be a mere combination of two things or something which is very obvious to anybody who is trained in that particular field. A very interesting example in this case I found is like it's a case of maybe I think this particular invention was shown on Shark Tank, where this particular person has combined a stepper with a pram. Okay, so the pram where you take the baby out for a walk, and behind that he has put a stepper there. So the idea was, if you take baby out in the evening or in the morning for a walk, you can put the pram there, and then you can do your physical exercise, particularly for mothers. That was the idea. Now somebody will say it's just putting together of two things, but is it so? We have to think about it. Is there some novelty that has been brought into it? How about establishing a stability mechanism for that entire pram? Because the moment you will start doing stepping, it is most likely to topple, right? Then how do you ensure the stability of the entire setup? Yes. So that is where the novelty has to be brought in, and it was, I think that particular invention was under patent application. So then that is where this non-obviousness one has to think about. It should not be something which is very clear, very obvious to somebody who is trained in that particular field. Many times examiners will point out in your examination that whether your concerns regarding novelty or non-obviousness, as and when you will receive a response from the examiner. The last point is related to industrial capability, where what you're checking is basically you're checking whether this particular item can be of any industrial use or not. So that is the broad idea about the patentability criteria. And if you do manage to pass through this particular exam, right, like whether first check whether it is patentable or not, and then check whether it meets the patentability criteria or not, then you will be granted a patent. So what will happen if you grant it? It is like that piece of land around which you have now a barbed wire. You can sell it, you can use it, you can build a house on it and live it, you can build maybe a commercial property there and can rent it, right? So, but the most important right would be in not letting anybody use it. So that means anybody who now wants to commercially make, use, distribute, or sell, they can't do that without the owner's consent. So that is the most important right which can come. However, these kind of rights are not without its end, point. Why? Because if you think about it, think from a pharmaceutical point of view, right? And suppose a company comes up with a new drug, which is a solution to a very long-standing problem. Okay, and they have spent a lot of R&D on this, and they get a patent on that. Now, it is a matter of public health, yes. And you think that, of course, you need to support that kind of company. The government might think like that because they want to incentivize companies to do R&D. But at the same time, from a consumer perspective, it creates monopoly. Because if nobody else can use or sell without the prior consent, in economic sense, what we call as is a state-sponsored monopoly. That person will become the single owner and the producer and seller of that particular drug, right? So that is why this kind of state-sponsored monopoly comes up with the end date. So that we say that, okay, after that particular point, this particular information will now enter the public domain. If it enters the public domain, then anybody can imitate it, provided they have the capabilities, and will be able to produce what is popularly known as generic medicines, right? So generics are not fakes. Generics are basically the earlier patented drugs which are now produced by other companies who have also taken due approval for the same. So they come with the end date that is up for 20 years from the date of application. And as a result, once those 20 years are out, then it becomes part of the public knowledge. So then these 2-3 dates become very important for us: filing date, publication date, and priority date. I'll come back to it. Before we need to understand what are the different steps engaged in the patent filing. Okay. So first of all, you have to file an application. The application can be filed physically or through e-filing. E-filing rates are relatively lower, and because there were 4 main patent offices earlier. Each one has a domain in Calcutta, Delhi, and then Mumbai and Chennai. But now you can do e-filing, and examiner will check for the formal requirement before accepting, and then the application is kept secret for 18 months. And after the 18 months, on the 19th month, you have to file for a request for publication, and that is when they are published. And now it is made available in your weekly journal of the Indian Patent Office. Once it is published, you have to request for the examination, and in the examination, then examiner checks it whether it is part of that prohibited category or not, and whether it meets the criteria of patentability. And usually you will find that once examiner has gone through that, they will also issue you an FER, a first examination report. They will question you. That question can arise on either novelty domain, or it can arise because of the non-obviousness or inventive step domain. So that is how these are the different steps. After that, you have to respond to them. Nowadays, I think they are doing even online response to those kind of queries because they want to fasten the process. And if all objections are met, then patents are granted. This is the normal route for the grant of the patent. But what is happening? Our economy is growing. We are building a very strong ecosystem for startups and academia. So as a result, in 2016, government came up with a very novel idea where they said that we will allow for expedited examination, publication, etc. So if you're in academia, you are associated with certain academic institution, after filing, you can ask for expedited publication and examination. If you do expedited examination, what we have seen now, within a 2 years time period, in fact less than that also, now patents have been granted. Okay, because this 18-month criteria was largely from the perspective of the companies. They wanted that give them the time to develop the entire product and could be saved from their competitors and maybe introduce the product in the market. So that kind of give them a time period to deal with the competition. But for maybe startups who are coming with a very disruptive technology, or for an academia where you want your product should reach the market faster, and of course nowadays promotions are also associated if you are getting a patent or not, and then that is why they made a provision where it can be done faster. And in that context, this particular classification of filing date and publication date becomes clear. Filing date is the application date, and publication date is the date on which it is published. Now you will question why it has to be published, right? Why this knowledge should be published. Now this is very important point. Why? Because as I told earlier, we are the major consumers and the producers of intellectual property right sensitive products. As a researchers, we all know that knowledge is cumulative, right? Can you do something in isolation of what has already been done? Very difficult. Many a times we will look at the existing state of the knowledge, we will find gaps, and then we will say, okay, this can be done maybe in a better way. Or we define a approach which is very different from the existing researchers. You say that no, we are not going to apply this approach. We will pick up the biology's evolutionary approach and apply this here. But again, building on two sets of knowledge, right? So that is why this very nature of the knowledge makes that we have to ensure that whatever new knowledge is coming, that should be properly published and that should be properly accessible to each and everybody, because that becomes a very important milestone in your new research journey. That is why publication is important. And if you're going for a international publications, that is, sorry, international patent, you also want to protect your patent in maybe America or United States, UK or European or Japanese, those kind of countries, then you can go through something called as a PCT route, patent cooperation treaty route. And there what happens, if you go through that route, the date becomes very important for us, because the date that you can use in that is the date on which you have applied in your home country. So through that route, you can use that as a priority date. The filing date in the other jurisdiction will be different. Within 12 months, you have to file in the other jurisdictions. You can always ask for request or something, but I think within 12 months makes sense also, right? So then again, you can get this distinction, because the filing date in the other jurisdiction is going to be different, but your priority date can be the date of filing in the home country. Okay. So then again, we've discussed valid for 20 years. Again, just because the patents are granted doesn't mean that your responsibilities are done. You have to renew them timely. If you don't renew them, it will be considered as abandoned. And once expired, it cannot be infringed anymore, and patented invention enter the public domain. So these are steps we have already discussed. So this is one thing which I think in academia we really need to look at it, because many a times we do not look at a patent literature. We look at largely academic literature, right? So for all your research project, it will be a good idea to identify the keywords, go to the Indian Patent website and search whatever existing state of knowledge is there. It also helps us in identifying the future partners for our translation of the research, like which companies are already doing work in this area, and we should be able to do that. So there is this link. I mean, I'll share the slides. You can share with all the participants. And this is the link for e-filing, and there is a link for InPass. I think it is there. If you open that, the website is very slow, so I've taken screenshot, and maybe let me see if I can show that. खुल जाएगा इसमें, इंटरनेट चल रहा है? So here you can do that research. You can identify whether it is published or granted. You can do the granted. Then you can look at the dates. Let us say, suppose you want to see. So it can go really back. Suppose you say from this particular date to maybe the latest one, and this one, and you can find certain keywords. You have certain keywords. Any keyword related to your own project you are doing, you can mention. You have to give the full term. Solid, solid, oxide, dual cell, fuel cell. कितने लिखते हैं अभी, पहले देखते हैं क्या होता है. So it is 08 H77. 0 है कि O है? O है ना? It's very sensitive and so it doesn't many times. But you please look at this, huh? I think some lot of. So what will happen is, suppose I do that search. This one I have done it for electric vehicle, and I get results like this. Okay. So what does this result? This will tell you all the patents which will be covering that particular keyword. Okay. And interestingly, you can check the application number. You can go into that. It will give you the details about the applicant. You can go to e-register. If you go to e-register, there it will give you access to the entire document. They will have an abstract, they will have diagrams, they will explain what it is all about. So you can learn from it and know very well in this particular field what all has been happening. Can be a very good start for your work. You can identify the companies, you can identify other research group in other IITs or NITs or in other universities, India or abroad, who have been working in that particular field. You can also know the status. You can also know the status, whether it is granted or which stage it is in particular. And most importantly, if you find that somebody is trying to copy your idea, you can put up a opposition to that also. Okay, so it's always good to kind of know what is happening in your field, and this is because this would be the most recent one. Publications, you will give it sometimes, it will take 6 months, 8 months for review and then publish, and then sometimes there's a lag in terms of how we understand and all. But here also you will find that particularly the early publications will be there, and you will be able to identify the application oriented work which is being done in your field. So then in a patent document, I think two most important, you can say, aspects, which is of a specification and that of the claim. So specification, it is basically a techno-legal document which will give you what is the invention, it will disclose the best method of performing the invention. And whereas a claim will define the scope of your legal protection. What is it that you are going to cover, right? So for that bottle product, suppose we have developed whatever the technology was, we will keep in the specification. If we say that any, enable this kind of technology being put in a bottle, then that. This kind of a technology being put in a blanket or in a spreadsheets for beds, right? So you will kind of, identify the application and will define the scope of your invention much more clearly, because in case of a litigation, claims will become very important for. If you define it very narrowly, what will happen? Then anybody can infringe on it. People can copy. If you define it very broadly, then you might invite a investigate or a query from the examiner that this doesn't belong here. You're getting too broad about it. So this is about intellectual property rights. Like I said earlier, we need to understand and know different types, and apart from patents, two most important IPR which are of relevance for academia is first is the copyright. So copyright, again, it is given in different categories of classes of work, which includes ordinary literary, dramatic work, artistic work, musical work, then cinematographic films and sound recordings. So your artistic, your literary works become part of the protection through your copyright. And you will see that computer program per se are not protected, right? So your computer program, your source code can be protected through your copyright. Okay. And again, there you would have to choose. You have to think about it strategically, because if you apply for it, then you might have to disclose it. Since some people do not want to disclose it, they may not take the protection also, right? May not take the legal protection of it, but they definitely, as we said earlier, this copyright protection is not subjected to only legal protection. If you can establish, say for example, you've written a piece and you email it to yourself, right? And there's a date. and somebody wants to publish a similar thing, a very same thing, then you can always argue that given this, that I have written it before. Another important issue about the copyright is that copyright protection is particularly not about the idea itself. It is about the expression of the idea. Okay, so what's the difference? An interesting way to look at it: Bollywood movies. In a Bollywood movies, most of the movies are about a boy meet girl kind of, for instance, right? Different contexts. They may meet in different, maybe from different economic background. They may come from different castes. They may come from different religion, right? But ultimately, that is the story or behind there, right? If that is the case, that copyright can protect the idea, then nobody can build on it. Everyone's interpretation, expression, production is different from that of the another one. So copyright cannot protect the idea, it protects merely the expression of that particular idea. Okay, in fact, copyright is much litigated apart from trademarks. If you look at in terms of application, trademarks stand first, then comes copyright, etc., and patents. Copyright again very litigated, like in before the release of any new movie you will find iska case ho gaya, uska case ho gaya, right? Koi naya song popular ho gaya, then somebody will come ke to meri tune thi, right? So because of this, this idea that ideas cannot be, they are not given copyright, it's merely the expression of that which is given the copyright protection. And then there are industrial design. Industrial design, an ornamentic aesthetic aspect of it, and it may consist of three dimensional feature. In case of industrial design, what gets protected, you have to prove that it is new, novelty. Like in case of patent, we talked about patentability criteria. In case of industrial design, it is the novelty. All the school of innovations and school of designs in different area, institutions are very prominently protecting their industrial designs. So if you look at this particular refrigerator and you want to understand that where your IP will belong to, any technical issue related to compressor or its support or something will be protected through the patents. If you are looking at, design of the knobs, the way the handles have been put there, or the double shelves, then we are looking at industrial design. Okay, so if we are looking at the manual which is written along with it, then we are looking at a copyright material. Trademarks and geographical indications are largely beneficial from a business's perspective, and they help the consumer in distinguishing the product of a company from that of the B. So I've not covered it because from academia point of view, I thought this is something which is going to be important for us. Next, which I want to cover, do I have time? Or we have some questions or something? Can take a brief break. You have a question? Actually, in Indian case, we have a first filing requirement, but you can take an exemption from that. But India itself has become a receiving, patent office for international application, PCT. So you can file via Indian Patent Office a PCT application to other places. Yes, you have to apply that which type of application you are doing that in the e-filing. But the only thing is that if you file in other countries, you would have to translate, and the cost has to be borne. Particularly USPTO and those places. Indian Patent Office is very cheap in terms of academia and startups and all. But other patent offices, because of the currency, it becomes a bit costly. But if you get funding for it, then nothing like it. Get funding. CSIR at one point of time was filing a lot of application at USPTO. It was granted also. More than 2,000 patents or something like that. So now we come to this. This is about IP management in academic institutions. As I've been saying again and again, major producer, major consumer. So we need to define what IP policy is. And this particular IP policy, if you define the rights, etc., it's very important because it will help in the transformation of inventions into industrial process, product, and providing legal certainty. What happens is that if you have an invention and you're not going ahead with a patent application and you want to talk to third party about it, you will always be jittery about it, right? You can go for non-disclosure agreements, etc., but there will always be a fear in you that this idea can be copied, imitated, or maybe presented in some other way. So if you have already, put up a patent, you have a discussion with them. You can always mention patent application pending, and this is the number, right? So that comfort with which you can, reach out to the industry, it is facilitated through a proper patenting mechanism, even at an institution level. Now you think from a company's point of view also. Now, a company doesn't know what you have invented, what you are doing. They may have some idea about you. But the moment you say that you have applied for a patent, it will also give them a signal that you are confident enough to apply for a patent with your invention. So maybe there is a quality to it, right? In economic terms, we talk about information asymmetry. So technology market, where we are looking at this interaction between the technologies in terms of maybe consultancy or industrial support, is marked by this information asymmetry. The buyer doesn't know like what kind of technology is there. The supplier will be hesitant to disclose, and then having a patent facilitates this information asymmetry in the market. Then it also helps you in establishing good collaborative ties with your universities. Whenever you're signing any kind of an MOU with any particular university, industry, or wherever, you have to make sure there is a small regular clause regarding the IP protection of the outcome which will come out of that collaboration, how it will be protected. And then what is also happening is with the internet and modern technologies, we see more and more conflicts emerging with respect to ownership, use, etc. So one has to be careful. So, and we are also looking at nowadays a term called entrepreneurial universities, right? So where we are looking at that the products and the processes which are being now coming up from these labs, I'm sure Professor Palani would have talked about lab to market, or that kind of a framework. If that is what we are looking for, then IP becomes a very important part of that particular journey. So then how do you do that? Make sure that your institution has a policy, and it should be a document which clarifies the ownership, it clarifies the rules and regulation, it mentions and explains to the faculty member what to do in case they come up with that. And with respect to even copyright protection, what can be and cannot be done. Also, see, of course, as an academician, there is always a clause of fair use when you are using this copyrighted material for the teaching purposes. But you should not be making a small packet out of it and selling it to the students, and that becomes problematic, right? So we have to have a proper policy and an institutional setup. That institutional setup should include maybe an IPR cell, incubation center, technology transfer office, so that it brings together the this particular kind of a framework in which the technology which is now created in your lab is being facilitated to reach out to the market. And there is a model guideline also which was made quite a bit early, I think 2016 or 17. And you can look at those model guidelines, and it does tell you what should be clear in your particular document, including ownership and what cannot be patented, act that does not constitute copyright infringement, and keep a record of all legal and related documents. And again, whenever you're using anybody's brand names, etc., even in your slides, sometimes we just simply put the name, instead of putting the name of the companies, you put their logo. So we have to be a bit more careful about it. Make sure you have taken required approvals. So I think I will stop here, Archana, hai na? Or I should go on. You have time? Okay. Okay. Then now next we move. Is there any questions about the commercialization aspect? Not sorry, about the IP policy guideline. Does your institution have IP policy? Nowadays, I think more or less everybody, all institutions has it. As a faculty member, what we need to look at it is in terms of how it defines like your ownership over it. And in case of commercialization, what is the revenue sharing being proposed, right? And if there are multiple inventors, then how that revenue sharing will happen within those inventors. I think that will be asked by, in many places they have something called invention disclosure form, which you would have to fill, right? There you have to mention if you are in partnering with some other institutions, or there are multiple partners, or if there are multiple inventors, how it will be shared, etc. And in terms of copyright, please be sure that you're using it only for a teaching purposes, not for dissemination. Whenever you're using a textbook, then what are its you know IP, or you can say copyright protection that is given. And that also happens whenever we are publishing, right? So we have to sign that copyright agreement with each and every publisher. So after that, whether we can put it on ResearchGate or not, one has to look at it. Yeah.
But if everybody wants some paper of that paper with my person, is it the violation of?
Yes, they have to take, they will, in this particular case, take the consent from the journal, because you have transferred your copyright. That is why we make a distinction between, technology transfer and technology licensing. Because transfer would mean giving up ownership, which we do. Licensing would mean giving it for certain period of time. So licensing is like renting. Transfer is like selling. So, journal will have more say in that. And it will also depend upon the copyright agreement you have signed with the journals. Some journals, they say that, okay, your whatever the last draft was, up to that you can upload it on a website, right? Your the first or second draft. What you cannot upload is the final PDF version of the article which gets published. But you have to see whether your agreement allows that or not. There has been issues and concerns about it. So some allow, but many don't also. So you have to check that, and pre-print draft that you can upload. And there has been issues with the publishers of ResearchGate and websites like that also. Because it's a complex issue. Why? Because you want to kind of tell people that this is the work we are doing, right? And at the same time, if there are so many constraints on it, how would people get to know about it? Even publishers may find it a bit difficult, because if suppose I read a part of your paper, or maybe you have written a blog out of it or something, then I might get interested in that paper, and some may actually purchase it also. So then again, that is where this preprint version, what can can be uploaded, because the way it is published, it's very fast and easy to read, like a reading from a the Word document, a LaTeX document which you would produce out of that. So you would have to see what is the final fine print of that agreement with the publisher says in this regard.
And just like a patent, you have 20 years validity. Is it a copyright?
Copyright also, there is a 60 plus after the death of the author. बहुत लंबा है उसमें. 60 years, life plus 60 years. So you can imagine, if you are a popular textbook writer, then even your generations, the next generation, can also get the benefit out of that. Yes. And that has happened with many popular writers you would have seen, like Agatha Christie, or even for the Sherlock Holmes series and all. Now some of them are getting out of copyright. So they could benefit from it a lot. So, but they've taken about their personality rights, I think. Na? So, actually, the sound is like what happens with a song, it is recorded. Right now, this is the sound recordings. For a sound recording, you need a recording setup. There would be so song is very complex. The way we hear it, there would be a lyricist. There would be somebody who would have composed it. There will be somebody who would have given would have actually played the music there. There would be somebody who would have sung it. But when all of them are put together and they're working for, let us say, like Sony or some other company, then they would sign this agreement with them, giving up their copyright to the Sony, right? And it will also depend upon how those fine, small prints of that agreement will then depend. Yes. Then they may also argue that, we need royalty whenever the song is sung, if it does become very popular. So then again, the fine prints of those agreement, how do you define, and how do you kind of, find out your, balance between licensing and then, making money, that becomes important. So that is what we are going to talk when we are talking about commercialization now. So here, in case of a commercialization, what happened? First of all, you have to think about which IP will be relevant for me in this particular case. If you are somebody from a product design, you may rethink whether we really need to go for patent or whether we should be going for a industrial design protection. If you have written maybe an article, etc., then clearly it will be the copyright material. How will you find it? Easy way to look at it: what is happening in that particular industry. Okay, so what kind of protection is usually used? For example, if we talk about pharma, we know that patents would be a very important channel, whereas in maybe like we said in uh, uh, associated industries with media, copyrights might be more prominent. So you would have to see that. And again, you would also have to think as a startups when you look at these questions. If you're thinking about a commercial venture, whether you should go for only one or maybe two or three would be needed. So suppose if you're going ahead with a patent, you want to, figure out the geography of it, like you just asked, whether you want to go for national or international protection. In that case, you would have to go back to your institution and figure out if there is certain support for the foreign filing, etc., or not. And what is happening with the competitors. So this question, again, for most of us in academia, we will be going ahead with the licensing. So we can discuss more that. So what is this? If we are licensing, we have to look at what kind of agreement we are looking in terms of the other party. Different types of agreements are available. For example, exclusive, non-exclusive, sub-licensing, etc. Exclusive would mean that this particular party would be, using your license in this particular area for a certain time period. And standard practices in this particular case include conditions such as minimum sale amount, minimum technical. Say, for example, let's go back to that bottle we had, right? The bottle with the technology which can change the water temperature depending upon what is happening outside. Now you think about it, clearly somebody will say, why don't you start your own venture, have your own spin-off, you have incubators within within your institution, they will support it. But then you think it's too hectic for us, we don't want to do that. So you go to INPAS, you identify which are the major companies which are doing patent in this particular area. You realize Milton is one large player, we can reach out to them. Or maybe there is some small player within the vicinity of your own institution. So once you figure that out, you have to now think about what kind of agreement you want to enter into it. If you're looking at a company like Milton or maybe some other bigger companies which has an international reach, you may go for, let us say, exclusive, but then they will become only the exclusive owner for that particular technology for that particular time period. Okay, but you think that no, we want to, maybe we want to support maybe the small players in this particular area, then you say, okay, we will identify maybe small medium enterprises which are working in this field and we will license our technology to them. So you give one license for north, one for south, one for east, and one for west, like that, right? But will be exclusive for that geography. Now when you are doing that, there are various things you have to think about, like how would you figure out the royalty agreement with them. Okay, what kind of agreement should be filed? It is like that, Bollywood. Suppose you are a hero, maybe like earlier that used to be the model. Earlier heroes, what they used to do, they used to get the lump sum from a movie and that's it, right? But that model has now considerably changed. Many has entered into production house. That is one. Alternatively, what is also happening is that many are now saying, okay, lump sum only this much, but maybe a share in the sales of the tickets which will be sold, right? So that is where you have to figure whether you want to lump sum plus royalty or only royalty. Why royalty is important? Because suppose your technology becomes big tomorrow, then you will be able to make money out of the different units which will be sold. Okay. There also you have to think about whether you want to go for sales or whether you want to go for profit. Always go for sales, because other company can always show very high cost and show कि profit नहीं हो रहा है, right? So but sale तो हुई है ना unit की. So on per unit sale, how much royalty would be given to you? Non-exclusive sub-licensing, you have to ensure that your agreement says that sub-licensing will not be allowed, because that would mean the person who has taken license from you can sub-license it to other party, right? So you said no, if we have to license, we will do it ourselves. So these are some of the points you can take into consideration. If you look at the process, so there are different major steps. First is the discovery. Somebody has to find you and you have to find somebody. There are nowadays certain agencies which help you. Otherwise, we have a National Research Development Corporation, quite an old corporation established during 1960s, and they will do the listing of the different technologies. And you know, you have to figure out whether your institution has an MOU with them. Can you list it there? And that will help you being discovered. I know of another platform in IIT Madras which can help you with the listing. Largely in our own institution, we are doing the listing also. So these are the different patent granted. If you're interested, you talk to this particular person via this particular person. Okay. So discovery, finding a suitable candidate is very important. And like I said earlier, if you're doing a patent literature research at that point of time, before starting the project, so we already know which companies are there, which would be interested in this kind of work. Once you do that, then of course the negotiation, contracting, in all these activities, you have to make sure some legal help must be there from your own institution, which will be there definitely. Like in our case, we have empaneled attorneys, so they will help you those details. But you also has to be aware about what is going on. So again, establish a strategy, figure out what is the kind of licensing rate in this particular market with the different industries. Do your background work, because otherwise you will not be able to negotiate better. Okay. Then see the draft contract, calculated fee, revenue sharing, due diligence. Also look at what would be your role after the transfer of technology. Now suppose this company says whenever a problem comes, you have to come and help us, and that becomes problematic. Then you say no, then we will help you only for this much time. After that, you please ask for a consultancy and we can go for that. Okay. What will happen if further developments happen on those two technology? Then what do you want to do, right? Whether you want to, who will own those further incremental developments? You will own it, or whether the company will own it. So these are some important issues, point you should have in your mind. And of course, once you have an agreement, then you will definitely have a post agreement management. You will look at in terms of what is going on. You ask them that suppose it is a royalty based agreement, then within the agreement make sure that there is a clause which says that you would have to the company has to submit their accounts annually or quarterly or something like that, because otherwise whether they will be paying royalty or not. So those are some post agreement management that you would have to do. So I think this is all I have to say. These are some of the examples we have. And like I said, certain impediments has been the awareness about it and directed. This is from our own research. We have found from surveys that sometimes low TRL levels. I'm sure you will learn more about TRL levels from Archana, and she can. And industry would always want higher TRL levels, where vis-a-vis, sometimes we get stuck into maybe 3 or 4 levels, and then there's a huge valley of death also. She will talk more about it. So these are some of the impediments. I hope you've gained something, and if there are any questions, we can take it forward now. I think now the government is providing you some 12, particularly for academia, 12 months grace period within that period. For patents, if it's already published, you can apply for patent. But now why do you do that? All of us are well known about it. All institutions have an IP policy. Always better to file for a patent and then do. You can do part of the publications, and with the idea, and you can mention that also the patent is pending regarding to that. And of course, the academic writing is going to be very different from the way you're going to write it for a patent. So, and then once you mention that patent pending, best, then you can figure out how you have to write academic. Public. So then you also have to think, suppose tomorrow patent is not granted or something, then what will happen, right? And again, like the domain of patent is very different from academic publishing. With certain works, you know that it will not lead to that level. You have to establish 3 things: patentability, non-obviousness, and industrial applicability. The work which is more relevant for a patent, I would say go for that. And usually what happens, earlier there was like works which were also better candidates for patenting. People were publishing them because publication is seen more prestigious in academia as compared to patenting. But now I think tables have turned, so I think you have to take a more balanced view, and presentation you can do in conferences, right, with the idea that patent pending. Oh, too many. Yes, yes. Recently, I saw some data. I don't want to quote because it's has to be checked. So, massive rejections are there. Of late, I don't know, but there has been rejections. Abandoning is also happening. A lot of patents get abandoned.
Actually, I'm having a question. If I'm working on any idea and I know that idea is novel, and actually I'm working on it, I'm in the position to build in future. So, if it is possible for me to file it, like to file it on the IPR side, then further go on or process my work.
See, the thing is, you have to take your work at a certain stage, because when you were writing that application, you have to establish novelty and non-obviousness. If you have not taken your work to a certain level, it will be very difficult to write that application. Just with the idea in your mind, that will be rejected, right? But if it is, another option with you is, if you have done some work but you think more work can be done, you can file for a provisional patent, and within a certain time period, you would have to file for a complete specification then, right? You can do that also. So there's an arrangement for that.
In this case, we can go for the file 9.
File 9 or form 9?
Form 9. We can go for
Forms I get a bit confused about. So I think Archana can help you much better. I'm not from legal background, so I will not commit on that. The web page never opened, Sharmila, sorry, but I will share the links. You can look at it.
Thank you, ma'am, for the enlightening and comprehensive session. Your address has provided valuable insights into innovation management and the critical role of IPR in research and technology development. Thank you so much, ma'am. Okay, thank you. With this, we conclude our technical session for the day, marking the successful completion of day one of the workshop. We sincerely thank you all the speakers and participants for making today's session informative and engaging. The workshop will resume tomorrow at 10 a.m. We look forward to your continued participation. Now, please join us for a tea. Thank you so much. Thank you all.